Curious. Does it seem a little smushy, or does it seem? Honestly, these ones are fine, and it's better for the people in the room. But like, I noticed the monitor is like a different resolution, and I didn't know I could technically. Like I said, it. Oh yeah, it's all good. Oh yeah, it's the right. Yeah, it's the right dimensions. It's just this monitor. That's fine. Not bad. We're in like 12:30. Should go get tacos? Still need. Nope. He's testing the stream audio, but otherwise it's good. Yeah. Testing, seeing if it comes through on the stream. Oh, it's marked mute.
Yeah. What? That's weird.
No, I know. It wasn't muting me like from these speakers. Whoa. Maybe that was what the feedback was. Maybe somehow I'm still coming through the speakers whether this is on mute or not. Maybe that's the problem. They've been having feedback issues. And he was like, yeah, you can just hit mute and it'll turn off your... No, that Shashi's playing with stuff.
I can hear you. There's a little bit of static, and we can get that worked out. Here we go. All right. I lowered it. You guys can get it doing FOMO -1 maybe
Is that me? Test, test, test. This is going to be the volume of the voice I'm going to be using during the talk. Probably about where I'm going to be. Hopefully the audio is coming through okay now. Nothing like some last minute AV. Gonna fix it all. Test and test. Everything okay? Auto-tune. Test, test, yep. Audio, testing audio levels. This is probably where I'm going to be. Voice volume wise, test, test. Does that sound good? Is that coming through all right? All right. Test, test, test. God help the people that are listening online, and then suddenly we'll figure it out midstream. And that's fine. Yeah. I'm just gonna go. Yeah, it's fine. Yeah, that's great. just want to make sure the stream was good. Yeah? All right. Awesome. Thanks, everybody, for being here today. I get a chance to talk about one of my favorite topics, and that is intentionality. And I'm going to explain what that means, how it'll bend back to architecture and design. And I was just really thankful for Aaron's keynote this morning, because I thought he really laid the inspiration, and I'm hoping to bring the framework of how you can take some of the things that he inspired you to do into action to be successful. But first, I want to explain why I think you should be here. I mean, you're already here, so thank you, but why I think you should care about this topic. And it's because I firmly believe that being able to explain why a system works and what it's trying to do is the fastest way to becoming a senior engineer. So after you get in through the door, the fastest way to progress through your career is to develop and work on your ability to explain why a system works and to understand how a system works. This is more important than learning another new language, more important than another new library, more than studying algorithms even. I think this is going to be something that you want to put in your tool belt as early as possible and start practicing. Conversely, and this is really kind of more of a recent thing, being unable to do this and unable to develop this skill or unwilling to develop this skill is one of your biggest risks to being left behind in this new sort of AI-fueled job market. If we believe that humans will remain in the loop with AI, the thing that we are meant to bring is our intuition, our discernment, our understanding, our wisdom. That's what we're there to do. If the only thing that you're honing is your ability to sling code, then I hate to inform you that AI will catch up with you eventually. As I was preparing this, I saw this talk recently, which I loved because I think it does encapsulate so much of what we're going to be talking about, and it was by Dexter Horthy, and he said, a bad line of code is just a bad line of code, but a bad part of a plan can be hundreds of bad lines of code. And a bad line of research, a misunderstanding of how the system works and how data flows and where things can happen, could be thousands of bad lines of code. And you can put in parentheses here, a bad system prompt, a bad rule could produce hundreds of thousands of bad lines of code. So yes, the code is important and it has to be correct, but you can get a lot more for your time by focusing on specifying the right problem and what you want. So we'll circle back, introduce myself. Hi, I'm Rob. I'm VP of Innovation at This.Labs. Got almost 2 decades of experience professionally being a developer. I host the Modern Web podcast. You can follow that link there if you haven't listened to us before. If you follow Tracy online, you've probably seen my face once or twice. And I have some hobbies. Now, let's get started. An email arrives in your box. Maybe it's happening to some of you right now, and you're working on it. You've just been assigned a new bug, a new issue has just emerged. What is the very first thing you do? Roll your eyes. Again. What's that? Reproduce it, yeah. So maybe the first thing is you recreate the issue. Make sure you can see the same thing that the testers saw. Maybe you just start debugging, just getting data. Go get log files, get as much information. You're going to need it later anyways. Or maybe you write tests. You go, okay, well, if I can write a test, obviously a test didn't catch this bug, so I'll write a test that'll catch the bug, and then I'll know when I've fixed it. Now, is there anything else? And I would argue that there is something that you should do even before any of these things, and that is that the first step towards fixing a bug is to understand what the system is supposed to be doing anyways. How many times have you opened up a bug and what you realized was, that's not a bug. That's just how you want the system to be. It's doing exactly what it's supposed to be doing. You just happen to not like that. That's a feature request, right? Or maybe they misunderstood the requirements. Or maybe it is the case that the requirements are wrong. And what you need to do is not just fix a bug, but you need to get a group of people together and fix the requirement and then figure out how that requirement change is going to propagate through your whole system. So don't start working until you actually understand what it is you're working on. And that explains a little bit, or at least as an intro, to how I once earned my salary in a single day. So I was joining a new team, and I was going to be the tech lead, but they said for a couple of sprints, why don't you just work some tickets? That way you'll learn the process, you'll learn what the system does, and then you can kind of graduate into more leadership roles. And I said, that sounds great. So I took a ticket, and it was for a shipping module and sort of a larger product suite for like running businesses. And it had a professionally done UX flow. It had a UI design that were all approved by the client. It had a set of requirements that were developed by a professional business analyst, and again, approved by the client. Now, one would think all I had to do was code it. Now, my dad has a family business, and I didn't work in the shipping department, but I knew a little bit about how it worked, and as I read the requirements, something didn't seem right. It just didn't seem like it was going to work. So I took it to my manager and I said, I know what I'm reading, but it doesn't seem to make sense. And so we went back and they looked at the notes and they said, no, you can see here in the notes from the client, that's exactly the way they want it to be. But I agree with you. It doesn't seem to make sense. So we went back to the original interviews with the users, videos we had taken where they showed us how the current system that they used worked. And sure enough, it was not going to work. And what had happened was, what had become the requirements was what the boss wanted the process to be, not what the process actually was. And that sort of telephone game had produced this issue. Now, what happened was, I didn't develop that feature that way. We solved it then. I didn't spend the time developing it, then us spend the time testing it, then releasing it, giving it to the client, them hating it, putting in an emergency ticket because their shippers can't ship things properly, us have to solve it under duress, repatch it, refix it, retest it, and resend it out. Stopping for a second up front and asking, does this make sense at all, was the key to saving tens, if not hundreds of thousands of dollars. Software is expensive, y'all. And so any amount of due diligence, any amount of intentionality you can have up front can save so much time and money. So that leads us to what I keep saying this word, intentionality. How do I define it, and how should you understand it, at least for the purposes of this talk? Intentionality is the process of understanding for every unit of code, every team process, every task that you do, not just at work. You can take this into life as well. You ask yourself, why am I doing this? Know your why. What can I understand and agree to be true of the things that people will give me as the inputs to this? This can be the arguments to a method, the inputs to a module, or it can be the requirements I received. What do I know about them? What can I assume to be true about them? And what should I hold those people responsible for? What should be true of the things that I give back out? True of my return values? What are people expecting of me? And what expectations do I have to meet? What do I want this to do, and how should it work? Not how will it be implemented in code, but what are the elements of the solution that I want to be there? Do I need to talk to certain systems? Do I need certain amounts of security? What are the things and the ways I want it to behave? Also, what kind of things should be defined or left undefined? You might feel like, as a developer, and I get in these conversations all the time, right? We love finding edge cases. We love solving every conceivable condition in the universe, but great swaths of them don't occur in normal life. And so sometimes you don't have to solve those problems. So deciding what you're going to focus on and what you're not going to focus on can be intentional as well. And it's important to note here, especially if you're a junior, you might be saying, Rob, I get that, but I don't know that I'm right. Being intentional does not mean you are right. Sometimes you will not know what you're doing. I don't know what I'm doing at all times, but the point is that if you are intentional, you will just not have mistakes. You can only have things that you will, or lessons to be learned, right? So you won't have, you're not going to be perfect, but you're going to have mistakes that cause you to have learnings to be better in the future, and that's what this promises us. So what does low intentionality sound like on a day-to-day basis? And you might have heard some of these things on your team. It sounds like, hey, I don't know, seems to work, right? This leaves you vulnerable to half fixes or regressions. I had this once. We couldn't solve this one problem. Somebody, I mean, everybody's done this, right? Well, maybe not nowadays. Now it's ChatGPT, but at the time it was Stack Overflow. Found a piece of code on Stack Overflow. We just pasted it in, fixed the problem. Seems to work. We don't know why, but it seems to work. A couple weeks later, we were testing for release, and we had this really hard to reproduce but persistent crash due to a timing issue. We could not figure out what it was, and eventually we figured out it was this line of code we had just copied from the internet. We finally figured out what it did do and realized that it caused other issues that were far worse than the problem it solved, and we actually solved the problem for real. It sounds like, hey, I did what the ticket said, right? This is kind of like the story I said. Don't sacrifice your agency. You are responsible for delivering the best for your users, for your customers, for the people in your life. You can't hide behind somebody with more seniority said to do it. Somebody else, being paid more than me, said I should be doing this. You are responsible for understanding what you're doing and putting forth the best work for your clients. Or maybe I didn't know that was used there. This one comes up a lot when somebody has written some code that they intended to be used within their own module, and you, being the responsible engineer that you are, said, I just want to not rewrite code. So you go and you find a piece of code that does sort of the stuff you wanted to do. And you go, okay, I'm just going to use that. But that code wasn't meant to be used by you. It was meant to be used in that module. And so when that person comes back and changes the way that their module works, they didn't know they were breaking your code. So this is low intentionality because, yeah, we were trying to do the right thing, but we used something that was not intended to be used in that way, and we didn't bother to update anybody or inform them that that was happening. So one of the ways that we demonstrate intentionality in work, and it's sort of, you saw this maybe in the talk title, and maybe that's why you're here, is through the idea of software designs. This is where we communicate to others what our intentions are and that we understand what we are doing. And so some of the things which is sort of like high intentionality is you start to show to people that you know what your user needs, that you know how the system should act, you know the context into which the solution fits, you know how you'll build it, and you know the alternatives that you're not going to implement and the trade-offs. So the overall objective of this, of why we write designs and why and how we demonstrate intentionality, is to prove to a context-aware third-party dev that you're building the right thing, you're building it the right way, and to a lesser extent that you know the answers to their questions. And let me explain a little bit of each of those things. So why context-aware dev? We need to assume that the people that we're communicating with at least have a basic understanding of what we're doing. We are not trying to bring laymen or non-technical people all the way up to speed. That's just too much work. But you need to understand that you're communicating to your team. Your team knows many of the things you know, and some things they do not. So you want to bring someone that's mostly up to speed through to this understanding. You want to make sure that you're building the right thing. In other words, you're solving a problem that needs to be solved, and you're actually solving it. You need to show that you're building it the right way, meaning that you not just solve the problem, but you solve the problem in a way that doesn't hurt the system in other ways, and we'll talk more about this. And lastly, that you know the answers to their questions. I don't want to steal a joke I have later, but many times when you talk to somebody about what you want to do, the answer they have is, well, that's not how I would do it. And you want to show that you've already thought of the thing they're thinking of, but that's still why you went the way that you went. All right, this is the template that I have developed for my team. Linda knows this design template. Yeah, she's been using it for years. It's awesome. And you don't have to do exactly this. These are just a set of things that I have found useful over time. As I will say many times in this talk, you just simply need to do whatever works for you where you are. And if you keep following the processes the way I'm going to say, trust me, you will eventually have a more rich and a larger and a more complex design process that you follow over time, and it might look a lot like this. I'll share this template on Twitter after the talk. So the first part of the design that I think is to first admit that the thing that we are not trying to do is prove that we are smarter than people. A software design is not a way for us to brag about how good we are and how bad the rest of our team is because they can't understand our brilliance. It's to have a shared understanding. And so we first start humbly by sharing terminology. What are the acronyms we're going to use? What are the terms? What are the third parties? What are the things that my team might not know or might need defined, so that we have no confusion, no ambiguity? Listen, use the best, most complicated, most precise terms you want. Use the precise names of software design patterns. That's fine. But bring people with you. Explain them. And if you don't know what to put in this section, that's fine. But when somebody comes to you and says, I don't understand what this word means, add it to the section so the next person understands. The next section is context. Context is anything external to the code and the system that's relevant to the design. How did you know what problem you needed to solve in the first place? How did you decide what solution you were going to have, right? This is any emails, meeting notes, conversations, videos, UI UX design, sample data, anything that informed what you were going to solve and how you were going to solve it. Make it available to people here. Don't put all the text in maybe, but like links to it. Where can people find it? You want people to be able to see what you intended to do, what your understanding of the problem was, and sometimes they need to go back to the original documents because they might say to you, hey, I don't think you fully understood what they were saying. And of course, in a design, I think most people are like, a design, that's just like requirements, right? And like maybe some text. Requirements are a big part of a design. And I want to talk a little bit about a couple different things about them. First is, I believe that what you want to put in your design is a minimal set of requirements that must be true of all software that fulfills a user need. And that maybe doesn't sound as profound as it should be to you. I won't make anybody raise their hand, but I'm assuming there are some people in here that still sometimes struggle with the idea that when you have a set of requirements, that defines a single piece of software that meets those requirements. I talk to people about this all the time. They get confused. They're like, I can't see the one system I need to build from these requirements. I'm building the wrong system. You need to see requirements as sort of a bounding set. There are infinitely many softwares that can meet a set of requirements. You can use different languages, different libraries, different approaches, different algorithms, different whatever. You just need to pick one of them. And so in the requirements section, you need to tell people this is the minimal set of things. If you develop any piece of software that meets these requirements, it will meet the business need. And if it doesn't, it won't. That's the perfect set of requirements. You want to avoid having requirements that over-specify, meaning that it constrains you unnecessarily to things that are actually superfluous. So functional requirements define what the software has to do. Those are the things it has to fulfill. And non-functional requirements sort of describe how the software will perform those things. In other words, how well it will do it. These are also sometimes called the ilities. So scalability, maintainability, modifiability, compatibility, performanceability. These are the hows. And all requirements need to be clear and measurable. What does that mean? It means that you can't say one of the worst and most commonly misused requirements, the system's got to be easy to use. What does that mean? The system has to be fast or responsive. What does that mean? How will anyone know whether you've satisfied that or not? A good requirement is one in which two people looking at a system cannot be confused as to whether the system satisfies it or not. That's the level of unambiguousness you need to have. And lastly, don't just describe how the system behaves now. If you are writing requirements after the fact, don't just describe what the system is now, because you can only ever then validly produce exactly the system you built. Why is that important? It's important because at some point you may want to refactor your system. You may want to add a new feature that's going to change a little bit how this module you're about to build behaves. And if you have written your requirements such that the only valid solution is exactly the one you built, you won't be able to accommodate that request. So make sure you have that minimal set. The next one is the architectural impact analysis. Sounds super fancy, but what it means is that you understand your code is going to go into an existing system. And so you're going to explain and demonstrate to somebody that you understand where that code is going to go and how it's going to impact that system. So you're going to say, hey, in what ways does what I'm about to do harmonize? Right? I'm about to add a security feature to my authorization system. That's security going into security, right? That's great. I'm doing the things the module that I'm affecting wants to do. I'm adding to it. I'm enhancing it, right? Maybe the system that you're building in also has a big thing about maintainability on your team for whatever reason. And you go, this is how what I'm going to do satisfies that architectural goal of maintainability. So how do you harmonize with the parts that you're going into? But maybe, how does it disrupt? Listen, maybe you're going to go add security features to your high performance module. Performance and security run at odds with one another. You need to show that you're being intentional about where those trade-offs are going to be. You can't get both for free. They have to trade off with one another. Say that that's a thing that's going to happen, and explain where you think you're going to draw the line so that other people can evaluate where you decided to draw those lines. And lastly, recognize that you don't just impact code, you also are part of a company, you're part of a team, you're part of a product. You're going to potentially affect other people. So will what you're doing cause additional DevOps work, new systems to be brought online, new processes or teams that need to be created? Does it require standards work? Will it maybe block another team from releasing over a period of time? Show that you also understand how your code and what you're working on is going to impact other people. Again, so that other people can assess that and help prepare people for that. All right, that was a lot of setting the stage, and we haven't even said what we're actually even going to do. At this point, we could hand off this design to somebody else, and they could figure out what to do, right? We've given them all the tools to come up with the solution. They just need to come up with the solution, but now we get to do it. And we're going to start that with the behavioral specification. So again, we're not talking about code yet, but we're going to document all the ways the system can be interacted with and how it will behave. So this is how the user would experience it, not how the system will experience it. So the user pushes this button and this happens. The user pushes this button in this state and this other thing happens. Again, we're not talking about code. This will be the contract that the code has to fulfill. You're just demonstrating and walking through all the cases and how you want to handle them. these become your test case checklist items, okay? These are, I was on a team once that this is what we did. We basically set up all our test cases before we wrote any code. After we wrote the code, we came and edited the test cases a little bit, update how the UI actually functioned, how you got from step A to step B. But that was our checklist of all the functional tests we wanted to create, was this behavioral spec. This is also where you can find where there's maybe gaps in your understanding of implications. Somebody can say, hey, you're forgetting about this edge case. Course design specifics. Lay out in as much detail as necessary how you're going to implement your solution. Think about potentially how you might give this to somebody else to actually do the coding part. What might they need to know? What patterns will they need? What modules might they need to create? Libraries, how will they manage their data? APIs, contracts. You can decide how deep you need to go, both for yourself, for other people to understand what you're trying to do, and for you to have the most success in working out potential issues before you get there. This section can be very small at first. Again, as you discover that you need to put more detail in there, then let it grow naturally. Don't force yourself to write 50 pages and specify absolutely everything. You may take completely the joy of coding out of it for you. Find what works for you, build up to what works best for you long term. Now, as I said earlier, and this often happens, right? I mean, people probably get this in the code review, right? One of the first comments you see show up on a code review, other than looks good to me, is maybe, why did you do it that way? I wouldn't have done it that way. Have you thought about doing it the way I would do it? So that's why we document the alternatives in the design as well. So for every choice we didn't make, let's try to document it and justify why our choice was better. If our decision was arbitrary, it's okay to say that. You can say there were 3 choices. I didn't know which one to pick. I just picked one. That's good. Then somebody understands the level of conviction you have in your choice, and they could maybe suggest something different. When people understand the decisions that you make and how you decide them, they can say, listen, I didn't agree with the way that you evaluated those options, or I didn't agree with the way you scored one of the choices. Or they might say there was an option you didn't consider that I think would have scored higher. You can start to see we're having better conversations, less about what I prefer and what I would do, and more about these are the rules of the road that we agree that we want to follow, and I just think you didn't apply them well. Much better, more collaborative things. So this could be an example here at data management. So like maybe I consider using context or Redux. And in context, yeah, it's using built-in React tooling. It'll handle my simple case well, but the rest of the app is already using Redux, and there are some side effects that I might need to handle, so that's maybe a downside. For Redux, like, does the side effects good, and at least somebody that reads the app will see we're using the same thing everywhere, but the boilerplate can be confusing, and it's overkill for my simple feature. But I'm still going to choose to use Redux because I value consistency. That was how I made my decision, and that's why I'm deciding to do that. And the side effects can be tricky, and I'd much rather implement it more simply. This is an example of how you can show that. So obviously a reminder that when it comes to design decisions, there's seldom an obviously correct answer. As I said before, there are infinitely many systems that meet a set of requirements. So focus on justifying your selections and by referencing the earlier material. Why did you make those decisions? Not because of your personal preference, not because you read it online, but because of something you already put in the design elsewhere that led to that. Okay, so you finish your design, what's next? Obviously implement your design. You want to keep notes. How did it go if you can't remember? And then after the release, when things have calmed down, go back and look at it and say, where was I right? And where was I wrong? And where was I really wrong? And how would I like to do this process differently in the future? It's not about regret. It's not about fixing the problem you already solved. It's what could make me successful on the next design that I do. Is there a section I need to do? Do I need to do something differently? This is part of an iterative process. No, we're almost there. This is part of an iterative process of improvement. This is why I think goes really well with what Aaron was talking about today. About planning, doing something intentionally, then executing on it, taking some notes or some data, then reviewing those notes and that data and incorporating it into a better plan in the future. This is how you get better over time. I don't know if Good Place still plays these days, but you too can become Maximum Derek through this iterative process of constantly reincorporating new information into your next iteration. So in conclusion, why is intentionality a superpower? First of all, you get fewer critical structural defects by thinking through the hard problems early. Secondly, because every mistake is a learning opportunity. You get out of the blame game and you get into this idea of, wow, we were all trying to do the right thing. We followed the plan. The plan just didn't get us there. How do we make a better plan in the future? It's a much more collaborative, much less fight-driven type of thing, less ego. It's easier to collaborate with other developers because, again, you're being so clear about the decisions you make, and anytime you're reviewing something for somebody else, you can always go back and see why they made those decisions. Code reviews get easier, code gets easier, meetings get easier, all of that. You can also develop code faster, especially with AI. All the things and the ways that you're going to describe things in a design that make it easy for humans to understand, AI really understands it, and it helps you reduce hallucinations and get a lot better code out much sooner. And you get caught up less often on syntax errors and bike shedding. So final takeaways, commit to doing these things, and I promise it'll do good things for you. First of all, commit to no magic. Never commit new code that you don't understand how it works. It's fine to test things, but once you've tested it before it goes to production, take the time to understand it. Always plan before acting, even if you only have time to write a paragraph of what you're planning to do. Just commit to it up front to stop yourself from cheating afterwards and saying, well, yeah, that's what I wanted to do the whole time, right? Put it down on paper so that afterwards you actually have something to review. Quid pro quo, help each other grow. Solicit reviews from other people to improve and review their stuff. This is how we help each other. I show you what I've learned, you show me what you've learned. That's how we collaborate and grow. And lastly, solve first and code later. Too many people get way down in the weeds and they ask like, I need to figure out how to do this syntax thing in this language. And the first question is always, why do you want to do that? Well, because I need this feature. Why do you need that feature, right? Start with the what problem you're trying to solve. Let that trickle down to syntax. Don't get so bogged down immediately into syntax. All right, thanks everybody. That was a lot. That is the slides, and as I'm closing out, I would just remind you that Danny's team and I would appreciate any sort of feedback. So if you go to the schedule again, you can click on the session, you can leave some feedback, your thoughts on it, and I think later that's also where you can get another link to the slides and the recording as well. So have a great one.
Are we good to go? All right. So I think I'm the one talk between you and lunch, so I'll try to make this quick. We're here today to talk about ADRs, and those are architecture decision records. But before we do that, we're going to build a project. So I want to build a web app that helps me have my kids track their chores. So as a parent, I want to be able to add kids, and I want to be able to add chores. I want to be able to assign chores to kids, and then as a child, I want to be able to check chores off. To make it more fun, because nobody likes chores, we're going to assign points to certain chores. So if you wash my car, you get 100 points. That way, they're more incentivized to do those chores. So now that we know what we're building, how are we going to build it? What are you going to use for the front end? Are you going to use vanilla JavaScript? Are you going to use React, Vue, Angular, maybe something that's not even on the slide? When you pick one of these frameworks or technologies, I want you to think about why you're picking it. You don't have to tell me why you're picking it, but I want you to keep that in the back of your mind. Next, we're going to talk about styling. This one apparently is a very controversial topic. Show of hands, who here is Team Tailwind? All right, a lot less than I thought. Okay. This is a judge-free zone, so next, we're going to talk about frameworks. Are you going to use a framework? Why or why not? If you're in the React ecosystem, there are a ton of frameworks to choose from. So again, pick one, maybe don't pick one, but know your why. State management. Again, there are a ton of choices. Are you going to use context? Are you going to use one of these libraries? What are you going to do? Backend. Do you need a backend? Maybe you don't. Maybe you're going to use a backend as a service provider, things like AppWrite, Superbase. Maybe you're going to go with one of these that are on the screen. And then we're going to talk about database. Where are you going to store that data? Are you going to go SQL, no SQL? If you're going to go with SQL, which one of these flavors are you going to pick? Now, I'm exhausted, and we haven't actually built anything yet. But that's what software development is. It's just a bunch of choices that you have to make over and over again to solve different problems. Now, if you think about your why, I'm willing to bet that there are no two people here that have made the exact same choices all through the stack. And that's because we all have different reasons for what we picked, right? Some of you might have picked a technology because you wanted to learn something new. Or you have a job interview, and that job requires a certain stack, and you want to show that you have work in that stack. Or you might pick something that you're already familiar with. So if I'm familiar with React, then I would just want to go fast, and that's probably the one that I'm going to pick. But we all have our different reasons, right? Enterprise software is exactly the same thing, but on a much larger scale. A lot of times you have a lot more decisions that you have to make. Sometimes you're not even the one making those decisions. Sometimes it's people who are more senior than you, who have more experience, have been at the company a lot more. They understand the problem that they're trying to solve. So those choices that we went through, there are a ton more. You think about observability, testing. Sometimes you work in industries where you have to worry about compliance. Maybe you have to worry about certain regulations. Each of these choices depend on some of the constraints that exist within that organization. I would be very impressed if there's somebody that knows all of these icons that are on the screen. Don't ask me how long it took me to create that slide, but it was a long time. So let's say you join a company, and this is their tech stack. jQuery, Oracle, and Java, and you're like, what the hell? This can happen. More likely, you're working at a bank, but you weren't there when those choices were made, right? You're probably thinking, why? Why pick those things? Nobody on Twitter uses that technology. Like, use something that everybody's talking about. But you don't have that context. You don't have you weren't there when those decisions were made, right? Maybe you're like my friend Aaron here, and you're like, I wish I was in the room where those decisions were happening, where those decisions were made. sometimes the people that made those decisions aren't even at the company today. And so some of those reasons might be lost. They might be watered down. Sometimes it's like a bad game of telephone where like one person says what they think the context or the reason was, and it just kind of passes down, and the original intent is not the version that you get. Now, I don't have a magic 8-ball or a crystal ball, and I don't have a time machine, so I can't help you go back and figure out why they made those decisions, but we have a way to move or to capture some of those decisions moving forward. And that's where architecture decision records come in. I was pretty proud of this AI-generated image. It was the best one that it generated, so I put it in the slides. So architecture decision records, that's a mouthful. So from now on, we're going to be calling them ADRs for short. But what are they? They are a lightweight documentation technique that's used to capture some of the important architecture decisions and their context. Now, I know what you're thinking, like, I don't want to write more documentation. Like, that's the last thing I want to do. But it's lightweight. It says so right on the slide. And it's highlighted, so it must be true. ADRs are meant to be very short, 1 to 2 pages at most, and they are typically written in Markdown. So they shouldn't be fancy Word docs with like all this styling and highlighting. There are a couple different templates that people use for ADRs. One of the most common ones is the Nygaard template, named after Michael Nygaard, who evangelized the term in a blog post back in 2011. I'll have a link to that blog post at the end of the slides. But when we talk about ADRs, I'll kind of run through like what is that made of. It's pretty simple. It has 6 main components. The first 3 are very easy, and then the next 3 are the ones that we're going to be focusing on. So the first thing that you need is you need a title. That just tells you what decision number that is, as well as what the decision was. So for example, if you decide to use React as your front-end library, then you would have the number of your decision. For example, if it's your second decision, it would be 2, period, and then use React as a library. The next one is the date. This one's pretty self-explanatory. It's just the date in which you made that decision. And then status. There have been, I guess, sources online that say that some of the other statuses that you can have are proposed and rejected. I haven't seen those very common. The 2 most common ones are accepted and superseded. Accepted just means that we've made this decision, everybody's accepted it. Superseded means that this decision was changed later on down the line by another decision. And we'll take a look at an example in a little bit. So the next 3 are the meat and potatoes of the ADRs. First, you need the context. What is it that we're trying to solve? Like, what is the problem that we need a decision for? It might be you need to store data, so you need a database. In that case, the decision is going to be what database you're going to use. What did we decide and why? In this case, you might have several options to choose from. You would say why you chose the technology or framework that you chose. Rob talked about it in his talk right before mine, but one of the things that we want to make sure people understand is the consequences. So why did you pick the tech that you picked? What are the pros and the cons of picking that? Is it going to make something harder down the line if you pick a certain one, or is it going to make certain things easier? What are the other things that you evaluated? Like if you're trying to decide between Postgres or MySQL or SQLite, and you go with Postgres, why did you pick that one over the others? Like, did it have an advantage? And then why were those other ones not chosen? So it kind of helps people reading that ADR later on down the line. It helps them understand that you did your research, you evaluated some of the options, and this is why you chose the tech that you chose. So just to kind of put it all together, this is an example of what an ADR looks like. You've got your title at the top with the date. I think date formats differ between different templates, so you can use the one that you like. status is accepted. And in this case, the ADR talks about how to create new files and apply small edits to the status section of existing files. The way that they decided to do that is to implement shell scripts. And then you'll see down in the consequences section, there will be differences, or it won't support Windows. So if you're using this ADR tool on Windows, it won't work. So pick something else. So that's, again, that's a consequence that they're aware of, and they want to make sure that everybody using this tool knows of that. So two of the most common CLI tools for the NiGuard template are ADR tools, which works on Linux and Mac OS, and the equivalent of it is ADR CLI, which works on Windows. But they do the same thing. The syntax to use them is the same, and we're going to take a look at that syntax here next. So you install your CLI tool. If you're on Mac, you probably do a brew install ADR tools, and then you're ready to go. The first thing you need to do is you need to initialize a directory in your project that tells the CLI tool where to put those files. So when you create new ADRs, those files have to go somewhere. So with ADR init, you give it a path to where you want those decisions to be. It doesn't have to be the one that I am showing here. It could be docs ADR, it could be docs decisions. It's just a matter of personal preference. So now that you have your directory initialized, if you want to create a new one, the syntax is ADR new, and then the title of your decision. So in this case, we wanted to use CSS for styling, and so that is the title that I'm going to give it. What it generates is a markdown file in that format. So you'll see the first thing, first three characters are the number or the decision number, and then use CSS for styling, which is the title just kind of with dashes in it. It auto increments, so every time you say ADR new, it will see what number you're at in that folder, and then it will generate a new file with the number incremented by 1. Now let's say you use CSS for a while and you're like, actually, I want to use Tailwind. You can create ADRs that supersede or basically override previous decisions that you made. And that's the thing, is like, just because you make a decision doesn't mean that you can't change it. Decisions are point-in-time decisions based on the information that you have. So things might change down the line, and you might realize, actually, I don't like CSS, just plain CSS, and I want to use Tailwind. You can make those decisions. You just have to add the -s in front of new, and then the decision that you are overriding. So in this case, my decision was number 3, and I'm superseding that with use Tailwind for styling. So some of the benefits of using ADRs is faster onboarding. How many times have you joined a new team and you don't know a lot of the things that they've done? Like, you don't know the tech stack that they picked. You're trying to ask questions, but some of the people aren't there, and it just makes it harder to onboard new employees and new designers, new PMs, if you don't have those decision records. Better decision tracking, context preservation, so all that context that existed at the time that you tried to make those decisions, those are there. A lot of times, in that example where we had like jQuery, Oracle, and Java, that may have been the tech choice 15 years ago, right? And it just hasn't changed. And 15 years ago, we didn't have React. We didn't have some of these frameworks that we're using today. And so having that context kind of helps people understand why those decisions were made. You can also avoid unnecessary rework. So let's say you join a new company and you're like, I think there's a better way to do this, and I think I'm going to do it. There are times where the team has already evaluated them, and they decided that's not the right choice for us at the time. And so instead of you trying to go implement it and wasting time doing that, that decision or those consequences are already they're already documented, and they said, we've thought about it, and this is why we didn't go that route. And it also improves transparency. If everybody knows the decisions that are being made and how they're being made, it kind of helps like the organization, the culture of the organization be more open, and there's not this like group of people that only they can make the decisions, and you don't get to know why they're making those decisions. So it just kind of helps the culture overall. Now, you're convinced you're going to use ADRs in your workflow. How do you go about doing that? I'm a big proponent of storing them in your repository. So documentation is hard enough as it is, not just writing it, but finding it. So don't store it somewhere where it's hard for somebody to find. Store it in your repo, that way it's all there. You can even use your favorite code editing tool. Let's say you're using Cursor. You can even ask Cursor questions about it, like summarize it, or why did this decision get made? And it's right there. It doesn't have to go reach for that somewhere else. Know what to document. Now, you don't want to document everything. You don't want to document whether you're using camel case or snake case or kebab case. You don't want to document what your folder structure is going to look like. Those are things that somebody just looking at the code base will easily be able to tell, like you chose this format. That's pretty easy. Things that are cosmetic or things that are like aesthetic, they'll document those. But document things that are hard to change. So if you choose NoSQL for your database, document that, because it's going to be hard to go from NoSQL to SQL or the other way around. AWS versus Azure, just things that require a lot of time and effort to change, those are the things that you want to document. Leverage AI. I'm not saying use AI to write it for you, all of it, but part of it. You need to make sure you understand the decisions that you're making. I think it's more important than ever that people know the trade-offs of the tech that they're choosing. We have AI tools that just kind of spit out code for you, and a lot of times people are like, well, I don't know, that's what Claude told me to do, or that's what Claude gave me. If you're in an interview and somebody asks you, why did you choose these tech choices, it's not a good look if you say, that's just what Bolt said. So you want to make sure that you understand what your decision is and some of those trade-offs and consequences of choosing those. Now, if there's one thing that you can take from this talk, it's that there is no best decision, right? Everything is a trade-off. What you might think is the best might not be what somebody else thinks is best. Strive for the least worst combination of trade-offs based on the information that you have available. You don't know what you don't know. Something that might happen a year or two from now, you don't know if that's going to happen or not. And so don't try to optimize for hypotheticals that might not exist. Just try to do the best that you can with the information that you have and the tools that you have. Now, decisions are hard. If you want to get better at making decisions, these are two great books, Fundamentals of Software Architecture and Software Architecture, the Hard Parts. I won't lie, they are thick books. So it might take you a while to get through them, but they kind of help you understand some of those trade-offs, like how to make better decisions as a software engineer. Now, some of the resources that I mentioned, the first one is a GitHub repository document of everything related to ADRs. The second one is the ADR tools that I used here on these slides. And then the last one is the blog post from Michael Nygaard where he first talks about architecture decision records. All of these will be available in the slides once I send them to Danny. And then don't forget, please send in your feedback. It helps me become a better speaker. It helps the organizers put on amazing conferences. So before you go to lunch, if you could find my talk in the Commit Your Code website, submit your feedback, let me know. And I didn't introduce myself. My name is Isra. I'm a software engineer with over 14 years of experience in web and mobile. I'm doing React Native and Expo today. But if you want to talk to me about any of those things, World Cup, Hamilton, how Diet Coke is far superior to Pepsi, come find me. This is a QR code to all of my links, my website, LinkedIn, Twitter, GitHub, all the things. So, yeah, thank you so much. And you get a couple minutes to spare.
Maybe like the first 10 minutes, but I just...
Oh, okay. Thank you for that.
Oh, are we ready? Testing. Can you hear me? Is it on? It's on? Okay. All right. Hi, everybody. Thanks for coming. My name is Sarah Shook, and I am a UI UX engineer at Hunter Industries. And I love CSS. It's fun. I like to try to do as much things with CSS without JavaScript. And so while I'm technically on the JavaScript track here, the only thing we're going to be using JavaScript today for is a click event. So everything else is going to be CSS. It is not off, but maybe it's not close enough. Okay, hello. Can we hear? Or I could just hold it. No, I need my hands. Okay, how many of you have ever felt personally victimized by CSS? So CSS can be sometimes complex, especially when you start getting to the 3D side of things. And so today we will cover CSS. We're going to go over the transform property just in general briefly in case you're not super familiar with that. And then we'll go into some 3D CSS properties and how to get the 3D CSS working and doing some fun things for you without JavaScript. We'll talk about perspective, a property called backface visibility, transforms, style, preserve 3D, translate Z, rotate 3D, and scale 3D. So we're going to briefly touch on those, and then I'll show you how to make a flippable card, and then we'll talk about ensuring accessibility as you're building out these 3D components, and then we'll go over some gotchas for the GPU, and just kind of things to know as you're building, whether it's with CSS animations or 3D CSS. So we're going to start with my code buttons. All right, so right now I have these, oh, why isn't it showing that? Sorry, y'all. Escape. There we go. All right, so we're going to start with these code pens. And so we just have two very basic boxes. We have our turquoise box and our pink box. And we're going to just kind of compare and contrast some of the different things that can happen whenever you're talking about transforms. So my blue box here is going to be not 3D right now. And so we're going to start with scale. So scale, as it sounds like, it's going to scale our box. Oh, that's not the right one. Hold on, y'all. Sorry. Oh, I'm going to have technical difficulties for a second. One moment. Sure. Yes, ma'am. How do I zoom on here? Let's see. Control plus, right? Well, we'll do it that way. All right, that's okay. Perfect. All right. We'll start with it. So we've just got our two boxes, right? We have a wrapper here just to put in the flip. And then we have our box 1, which is the turquoise, and then the box Z, which is going to be the 3D. All right, so why my box Z is not doing what I want, I'm not sure. My box 1, I don't know, because my internet has been flaky here. Perfect. All right. So as we can see, box 1 is scaling now correctly, and it's scaling up to 150%. Just center, the transform origin is center for this, so it's just scaling exactly straight in front of us. And so then we talk about translate Z. And so when you're talking about 3D CSS and just translations in general, there's translate X, which is going to be horizontal, correct? And then translate Y will be up and down. And then you have your translate Z, which puts it on the Z axis. And so when we translate Z, what you're going to find is it does not come out straight like our scale does. So they look very similar in behavior, except for one is coming out a little bit more 3D. And so in order to do that, we have to give our parent element a perspective. And when you come and you give the parent element a perspective, it makes a 3D scene. So you're looking at a scene now, and you can adjust that perspective. So 500 pixels is how far away it is to us right now. And then whenever we hover it, it's now showing that perspective of 500 px in that 3D plane. If we change that perspective a little bit, we can go to 200, and hopefully this saves. Yep, it saves and it goes way off the screen because our perspective is so much closer. And so with these things that I'm showing you, I'm giving, pixels. You play around with these for your perspective and because the size of your boxes matter. And then I also zoomed in on here, so it's a little bit off for me as well. So anyway, so we've got that. So that's the scale, and it's bringing it out. But then when we start talking about translating them into 3D. So we first have translate 3D, 100px, 100px, and 0. So what this means is it's translating 100px, x, so 100px to the right, 100px, I think it's, let's see, 100px, sorry. I'm having to use my mobile hotspot because the internet did not want me to use this here. So it does work whenever it reloads. I shouldn't have done this on CodePen, I guess. We'll reload. All right, there we go. All right, so 100px to the right, 100px down, but it's not, the 0 there is the z-axis, and so it's not giving us any z-axis translation. And then now, if we go to our pink box, we're going to have to probably refresh a second. Reload. There we go. All right, so now we've got 100px, 100px, but now it's scaling out 100px as well, or translating out in the x-axis. Then we have rotations, and I'm going to have to go back in just a little bit so that I can show you easier. Okay, so rotation. Sorry, guys, I did not expect to have these technical issues. It worked just a few minutes ago. It's not the CSS, it's the internet. All right, there we go. So now, with our box, we're going to translate 3D. We're not doing rotate like it was supposed to. That's okay. We'll fix it now. Thanks for bearing with me. All right, so now we're rotating one full circle. So with rotate 3D, we're doing, there's a vector of 3. The 1 is going to be rotating it on the x-axis. The first 0 is rotating it on the y-axis, and then the third is how many degrees. So we're just doing a full circle. And as you can see, it's rotating there. And then if we do it on this one, if it's going to work, oh my goodness. Hold on one moment. Never mind. I don't know where my phone went. I think that's where this issue's coming from. You've got my phone. Oh, maybe that'll work now. Thanks, Ryan. All right, so we'll try again. Rotate. There we go. So now it's rotating the correct way. But whenever you start bringing in the Z transition, whenever it comes to rotating, it kind of starts acting a little bit funky because the way that the Z-axis works is it works in a different plane, and so whenever you're rotating and doing things in the 3D plane with the Z-axis, you have to be careful and really figure out the best way to do it. And so I don't normally tell people to use ChatGPT or AI to learn the concepts, but when it comes to integrating the Z-axis, that sometimes is very helpful because it can figure out the math, but at least for me, better than I can. So because I'm having so much issue with this side, we're just going to go ahead and go to the card demo because I can do that. So does pineapple belong on pizza is our card, and Before you say no, I want you to remember in the keynote today, Aaron Francis said that it's not a good thing to be somebody who hates something and be known for that. So, and if you haven't tried it, you're not allowed to say no. All right, so with this, hopefully this will work. It's already built out. But we have our wrapper class again. Then we have our button, because we're using a button here, and we're going to have our 3D card for the button wrapper. And because we want to make sure that this is accessible, we're going to do some ARIA updating with our JavaScript click event. And so like I said, the only thing of JavaScript here is the click event, and I'll go ahead and show that here. So we're querying the card, finding the card by its class, and then based on if the card's value is pressed, then we're going to flip the card and change those ARIA values for the accessibility, and we'll flip-flop between the ARIA hidden on the front and the back of the card. So we have two card faces. I'm going to hide this now. All right, we just have our wrapper stuff here, and then we have our 3D card. So what we do on the 3D card is we give it a relative position. We go ahead and we have a perspective of 500 pixels, which hopefully will work well now that I'm still zoomed in here. And then we have our card faces. And the card faces are positioned absolutely on top of each other so that we can hide them and show them. And so within these properties, we've got a lot of just the style. So we're displaying it flex, we're displaying it on a column format, the text is aligned in the center. But then we have this property here, which I mentioned earlier, and it's the back face visibility. And so I'll show you what that does after I show how the card works in a second. So we have our back face visibility hidden. We have our transition set, and because this is a button, we make sure that the background is transparent so that we can flip it and you don't see any of the button or initial styles. And then we just have some basic styles for this. And then with our colors and our backgrounds, and then with the actual 3D card itself, we're going to translate and transform, rotate them depending on if they're flipped or not. Okay, so it works. Did not have any issues with that. So 100% yes. As you can see, you cannot see the back of the card or the front of the card now that it's here, and it just goes back and forth. Okay. If we did not have that back face visibility, now fingers crossed that this actually works correctly, fastly this time. All right. So if we take this now and save. I might have to come back to that, but I'll show you if it takes a minute. So if we did not have this, if I did not have tech issues right now, what you would actually see is that the back and the front, you would be able to see both of them. So the back face visibility says, hey, this is a 3D animation. We want to hide what's behind us that's going to be transformed so that you can't see the back and the front. Okay? Since I'm having so many tech issues, we're going to move on to the gotchas. And I apologize for all the tech issues today. So from current slide. All right, so whenever it comes to transforming and transitioning animations, there's what's called a rendering pipeline. And so that is going to tell you what is going to take the most energy or the most computation value and go. So so there's the layout, which is when you calculate things like the width, the height, the margin, the top position, the left position. When you transition or transform properties with those types of properties, it's going to adjust the entire layout. It's going to be very expensive computationally. So you try not to adjust the layout. We use transitions and transforms instead of adjusting top left. So like I showed you earlier, you translate X and translate Y, which moves those elements but does not affect their width and their height. They stay contained within their parent technically, and they just move visually. So it doesn't recalculate the layout whenever you don't transition width, height, margin, top, etc. Then we have paint. And so paint is when it's going to be drawing the pixels. So background colors, box shadows, borders. So if you have like a heavy background image that you're using and it's like, you know, full of flowers, and you translate that and you transform it and you're making it move back and forth, that's going to be expensive as well, because you're repainting that picture and all of those pixels every single time you move that element. And on smaller elements like buttons, things like that, it's okay to repaint usually. But when you're talking about having an entire background of your website moving back and forth, and it's not a video component, and it's redrawing it with transition and transform, that also is very expensive, and it can end up slowing your site down. And then you have what's called the composite pipeline, and that is when you are transitioning the least expensive. So that's transform, like we talked about, transform, and then you're translating it, or you're transforming the opacity. You are not repainting all of those pixels for each time that the frame is updated. So whenever you can, you should stick with the composite updates so that your transitions are smooth, and they're the most efficient. There's also a property that I don't have listed here called will change, and that is a property that can help if you have an expensive animation that you're going to be using, because it tells the browser, hey, this animation is going to happen and I need you to expect it to happen. But if that property is used a lot, then it also is very resource intensive. So it's best to try to avoid that when possible. All right, we kind of went over some of this. So gotchas, again, using transform and translate instead of top and left positioning. So always using those composite properties to move things around on your animations. When you directly animate things like box shadows, instead of actually animating under your element, you should create, if possible, absolutely positioned elements under your parent element, and then animate those instead, so it's less resource intensive. Again, I've already said this, but background animations are best on small elements like buttons versus things like backgrounds, because you could have millions of pixels that get repainted every single time you switch frames. And again, when sticking to animating backgrounds, use simple backgrounds versus complex patterns. And then I'll see real quick if my thing worked. I don't think it did, though. It's very disappointing. But that's really it. So I'm happy to answer questions. So sorry I'm caught off guard. I was not expecting internet issues right now. But CSS animations, even though they seem challenging, there we go. All right, there's the back face visibility right here. So because back face visibility is hidden, you can't see the original initial card up there. All right, so I apologize for the tech issues today. I was not expecting them. Any questions? Yeah. Yes, so I know that like Internet Explorer 6 does not work with this, but the examples I gave should work on most browsers. I will say that when I do CSS transitions and animations, not with these examples, but I find that Safari is the one that is the most complex to deal with, and I always have to figure out, why. But I don't have a specific example on the top of my head, but I've definitely had it happen.
Also, a follow-up on that, we would recommend something like Predictive to make sure that works on Safari.
Yes, yeah, and there's the WebKit OS. Yes, there are the polyfills. I did not include them in this, but yes, I would do polyfills if I needed to. Yeah, for sure. Awesome. Yeah. Yes.
Does the same concept work with Tailwind CSS?
Yes, and actually that's usually what I use is Tailwind CSS. So I was actually, this is all vanilla CSS. I guess it's It is CSS, but I usually, yes, use Tailwind. And then what I normally do if I'm doing something really complex, you can like create custom classes and custom animations in Tailwind, and I do that sometimes. But when it's like a one-off, I really want to see the actual CSS and what I'm doing. So I'll usually create like classes to add to like the CSS itself and write it all out instead of doing it on like my Tailwind config file, or I know we're in Tailwind 4 now, but I have not migrated to that quite yet. So.
You talk about the technical thing here, but like from an aesthetic and kind of your design sense, how do you balance animations and the joy that they bring versus making things like too distracting?
Yeah, for sure. So my favorite, I obviously went with kind of a more in-your-face type of animation for this because it was easier, would have been way easier if I could show you everything right away. But I think that the beauty about animations is really being able to create subtle updates and subtle animations that draws a user's eye to like a button or something that you want them to see, and you want them to like get excited that they submitted something. So like I love doing I usually will mix state within my like button elements, for example, and I will have like if I'm waiting for an API call, for example, I'll have a pending state for this button, and it'll have maybe a little loading icon on it, and then once the data is in and I have that success, then I'll change it to success. So it's very small changes. Maybe it just changes the color, maybe it adds an icon, but something subtle that still draws the user and gives them that satisfaction that the action that they've taken is completed or they're waiting for it to be done. Yeah. Yes.
I've always been really interested in animations because I think they're very cool, but I've been limited by knowing how to test them from an accessibility standpoint. How do you implement that, or how do you encourage someone to continue researching that?
I love that question, and I will be the first person to tell you I really love accessibility, and I am on a very small team, and it's not always the first forefront on the team that I'm on because there's only a couple of us, and so I do utilize ChatGPT a lot for ARIA. I feel like it's a very stable thing to ask it, and then when I have my additional time, I'll research otherwise, but as long as I can get something in and then I can build onto that when I have more time, just trying to at least make sure it's implemented as best as I can right then, and then go back and study and then re-implement things later. And then when you're building components, right, like you're gonna reuse them. So once you have it, it's not like you're having to do that for every single component. You have it in your base component, and then that gets inherited, whenever you're using it throughout your project.
To that end, surely like an ARIA label, and flip it, just changing the label to describe the text.
Yeah, and I had an ARIA label here. Yep, flip card to see the answer here. So, yeah. Yes, you're right. And I did not touch keyboard navigation here. That was not the scope of this one, but I do agree for sure. Yep. I'm going to see if it works now. Any other questions? I have been personally victimized by the internet on my phone today.
I guess a wild question.
Yeah.
Now that we know about the answer to that question, what about kiwi?
Oh, you know what? I think it would be great. Same with mango.
Or should
Well, that's all I've got, y'all. I'm so sorry again for the technical issues. But I will make these public on my CodePen, and then y'all can see them and play around with them and play around with the different properties. And then, let me share my Connect thing, because if you want to reach out to me with questions specific, I'm shook codes like everywhere, but there's my LinkedIn if you want to connect there. And I'm always happy to answer questions, and if I don't know the answer, I'll let you know. I'm really mad that everything wasn't updating it right away, but. Thank you, guys. Yeah.
So I'm very much a beginner still. CSS has traumatized me on multiple occasions. But what would you recommend? And maybe there's no like clear answer, but like
All right. All right. Oh boy, I'm live. This is going to be my first YouTube live, and thanks for coming to the session. Myself, Naveen Chetlapalli. I'm a solution architect working at Ashling Partners. Ashling Partners is a technical implementation partners with many companies like UiPath and Microsoft. We implement low-code and to no-code projects, and we are heavy into intelligent automation. Our goal is to become the world-leading #1 hyperscaler company. That's about Ashling Partners. More about myself, why I'm so much interested in this topic, you'll get to know. So this is going to be my agenda, and I have given the QR code in every slide so that you can go ahead and download my presentation. Feel free to, just go ahead and put your name and download that. And first of all, I'd like to discuss what, why, and how serverless, and giving some 101 about Azure functions. And what are some AI integration and best practices that we have learned and I have learned implementing a project internally, and a real world demo. But before I move forward, I'd like to present a short story. Once upon a time, there is a developer called John. It's all the days before ChatGPT was even launched. One day, he was working at his startup, and his manager came to him and asked him, "Hey, John, you should be handling a full stack application that we are going to develop right now. It is going to change our company's trajectory, and I want you to handle both the front end and back end." I already have enough on my plate. How could I do all the back end work? That's what John's thinking. But it is promotion time, so he couldn't say no. So he got a small email from Microsoft Azure saying that we will handle your back-end services, and you just need to put your code into it, and we call it serverless. That's where John was so excited, he clicked on that link, and he started going deep into the world of serverless. So John is like me, and it's like a funny cartoon that I prepared. So Azure Functions and Azure Serverless Functions is a solution that lets you just run the code, and Azure or any sort of cloud providers will handle the back-end portion for you. Just pay for whatever you are running the code on, and just you need to pay for the execution. That is called a serverless. So whatever that is going to be triggered, it can be any event, or it can be a gatekeeper that will be updated by your services or operations, and you can run and put your code on that. But why serverless? Okay, John is still sitting and having a pure bliss of having the coffee, but see what Azure is going through: a lot of server racks and keeping the service serverless options on 24/7, and also when there is an automatic scaling of multiple users running onto your front end, it will automatically scale and spike whenever it is needed. And the lazy John is still having a pure coding bliss. That's what and why, this is why you need Azure Serverless for implementation and cost efficiency. That's the major key portion. And let Azure handle the rest of your headaches of your backend. But I would like to say, how serverless? It is going to be a trigger and execute model. That means it is going to drop a file. It can be anything. It can be a HTTP request, it can be a file drop into your storage, or it can be a new queue message. It can be anything. Just lazy John writes his code and puts his triggers on command like a gatekeepers to show me whenever you want to do this, whenever you see something like this, just run my code. And the output can be anything. It can be committed to databases, it can be sending some email notifications, or even it can be some IoT devices or any values that you wanted to see on your devices. Oh, that's fine. But how did I implement this in my current role at Ashling Partners? So one day, again, my real manager came to me and asked me to fill a bunch of documents which I am developing for a project. Documentation is always boring. I don't want to get into that messy stuff. I want to put my hands dirty and write code, not document all the stuff. Then why don't I use Azure Serverless, whatever that I'm learning previously, into fruition and create an architecture to easily develop my documentation. It can be technical specs document, it can be solution design documents, it can be architecture documents. There will be a set of templates that anyone in your companies will be using for. All you just need to do is download those templates and put whatever the bunch of stuff that you wanted to write. And these days, you don't even want it to think. There is ChatGPT, there is Gemini, there is Claude, there is everything. Then I combined all of these things with the Azure Serverless, and I created this tool, internal tool called as Onslaught. It is an AI-powered documentation agent. I will also give you a demo what I have done and developed here. But I just built a small front end where I am communicating my backend to be Azure Serverless functions, and it is running a HTTP trigger. That means whenever the user asks for a documentation and he puts some simple description, says that, hey, this is my project, I'm going to build a project about an automation solution, and why don't you give me a documentation? That is going to trigger my function, which I have already pre-built, pre-written in my Azure, and it is going to communicate with my Azure Open AI services, which I have hosted my model on Azure AI Foundry, and then it is going to convert my stream of responses into a document, and it is going to send me an email. It is saving me a lot of time, at least 8 to 10 hours of time preparing and writing all the documents. So this is why I chose serverless, to automate my needs of creating and writing a document or any sort of documents. So this is how I developed it, okay? This is me now, not Lazy John. I'm going to open a lightweight Next.js application as a front end, and it is going to trigger an HTTP Azure function, which is going to make a call to my Azure OpenAI services, there is a model that I have deployed on it, and then instant documents where I can share it with anyone. Let it be my team member, let it be my manager. Of course, they know that I'm doing this heavy lifting work for them, so they even have motivated me in building and putting more templates into this tool. So we really liked it, and we really loved this tool. And we are also going to expand this kind of implementations to our clients, internal clients too. But you might ask me, hey, why don't you think ChatGPT or Gemini, don't you think they do this? They will definitely generate documents, but not on your own terms, not on your own templates. But this is something that we have uniquely come up with, and we have developed internally, which we wanted to expose it to our clients as well. So I'd like to quickly show you a demo before I go into the Azure 101, Azure Serverless 101. The reason I'm showing you this is to show you the capabilities of what can Azure Serverless functions do, and what are the type of applications that you can create with this, so that you can get a clear picture and you can try implementing it in your own style. So this is a small demo, and this is my application that I have built. This is the lightweight Next.js front-end application. So here, if you see, all I'm trying to do is just put my project description, and I'm going to generate a report type called as test case document. There are multiple report types: solution design documents, architecture diagrams, anything. And I'm going to write my description, and I'm going to give my email. There is no backend. All Azure Serverless is handling it in the backend, and I just need to pay for the execution. I don't even need to get into a subscription model or anything. It is just pay per usage, which is very user friendly for us. If I just type it, my email, and if I click generate document, all it is taking some time to communicate with my HTTP function, and it is going to convert that HTTP stream into a network memory stream, and it is going to generate me a test case document like this. It is going to just give me an attachment, and it is going to show you like that. So that simple it is. Even just for writing this test cases, my test developers or my test managers will take so much time understanding the concept, understanding the nuances of the idea of automation or anything that we are trying to do, and bring it into a template and bring it into a document. At least this takes some time. What I'm trying to do is just give them some kickstart, and based on this template or based on this ready to go document, they can take this and they can build upon this, where this is a big time saver. All right, hope you like the demo. Let's go to the next slide, and these are all the slides which will be covering my all Azure 101 things. Consider the Azure functions, whatever that I'm displaying or demoing you here. These are all the building blocks of what you need to mainly understand about Azure Serverless when you're trying to implement some. Whoever in the room know a little bit about Azure Serverless functions? Have you ever tried to implement? Oh, nice, that's good. So you might have some idea, but I'm also going to discuss what are some key things that we have learned while we are implementing this around our projects. So as I told you, these are the building blocks. You should understand about what are triggers and bindings. They are mainly like the gatekeepers of when or how the service is going to get triggered. It can be a HTTP trigger, it can be an event trigger based on any type of events that will be occurred. It can be a blob storage trigger. Blob storage is like a database or some data space where you can drop your files into that storage. It can be a timer trigger saying that, hey, for every this time, like a cron job, run this trigger for certain times or for certain days or certain weeks or a particular day in a month or something like that, and many more. And coming to hosting plans, you should also understand what are the type of hosting plans that you will be leveraging. Mostly for me, consumption plan is much more efficient. But if you are going to do for some enterprise ready and production ready interfaces when you are deploying it for large scale operations, you should be definitely considering premium or flex, which I'll be discussing in the next slides too. Language support. Of course, I am a C# developer in my past, but I also started using Python, which is much friendly, and ChatGPT knows more Python than C#, so I started converting my Azure functions into Python too. But yeah, it supports many languages too, like Python, C#, JavaScript, and you name it. And it is DevOps ready. Of course, you don't need to worry about deploying your service, deploying your functions from your local developer tenant to test tenant to production tenant. So there are some automated build pipelines where you can leverage them and you can put them into any of the tenants that you want. All right, let's discuss about some of the important things that we have learned. While we are implementing this, as I don't want to put some numbers to it, because based on the region, Azure provides you different costs for consumption, premium, and flex plans. These are the three types of plans where you can expect. But as I told you, right, it depends on how you architect your solution, how production critical is that, you should be choosing your plan. And mostly it is having the pay per execution plan, reserved instances, and it is the combination, flex is the combination of consumption plus burst. That means you reserve your 15-minute capacity or to run your services in a premium mode. Cold start is something that I want to stress on. As I started doing this operations of the internal tool that we built called as Onslaught in a consumption based plan, we saw some issues of cold start. That means, let's say I don't use the service over the weekend, and if I come back on Monday and if my developers or my teammates want to use this service, of Unslath, which is triggering the Azure function, HTTP's function, we used to see some cold start problems that it used to take some time to get it running. So that is one thing that you need to consider. Is it production ready, or if you want it operations to be much quicker, I would definitely ask you to go for premium or flex models. So yeah, the key features will be infinite scaling. You just need to implement the scaling functionalities and turn them on, where you can readily scale them to various number of operations. But the cost also definitely varies on how much your bandwidth is being consumed and how many requests are you getting through this thing based on the plans. All right, I'd like to touch a little bit on event-driven architecture. This is something we also implemented when our storage triggers are not working as expected. That means there are multiple projects that we have implemented using Azure functions, but couple of times when we created a blob storage and we are trying to drop some files, like some JSON files which we wanted to do some code reviews on it, or some image files where we wanted to do some image recognition or some document processing on that. So that blob storage was not particularly able to handle all the services, even though there is a trigger called as blob storage trigger. Then what we understood is there is a particular option called as event driven, and it is going to be a game changer for Azure functions. Like, there is only one instance of blob storage that we wanted to trigger, and every time a file that gets dropped into it, it triggers an event, and there is an event queue that will be created, and it drops that event into that queue, and it works in the first come first serve operation, and that is how this event driven architecture will work, like event publication and event grid routing, and it routes to any services. Like, you don't want to process all the PDF files, there will be a naming convention, certain things, then you can put some event grid routing operations there. And fan out and fan in processings. Fan out processing is mainly considering for multiple triggers parallelly running this operation into various streams and segregating and splitting them into various operations. That is how we also implemented some event-driven fan-out processing architecture. And event filtering, it is like, again, some images which we wanted to filter for recognition or some document capturing. We don't want to consider some sensitive data. So we are also filtering out some PII sensitive data using some event filtering options there. So this is all some sort of event-driven architecture I'd like to touch base on. And one more crucial thing is blob storage trigger, which is also one of the types that we implemented, including with the event-driven architecture, where you have file upload events and stream processing. Stream processing is something like you don't need to wait. Let's say you have 100 megabytes of video that you wanted to get some analytics on, to run some AI-powered insights on. You don't need to wait for all the 100 MB to be uploaded into that blob storage. So you can turn on the stream processing where it can be based on the chunks. Like, if 10 MB has been loaded, you can start processing your data, and next 10 MB can be segregated into that. So you can split that based on the stream processing. And batch processing is also something like, only if certain number of files are loaded, you will write that, okay, I will start my blob trigger processing. So that is where batch processing will be operated into. Orchestration is again same like fan out, fan in processing. So you segregate and split your operations of your blob storage triggers and understand how you can identify these. Also, I would like to also give some best practices that we have learned, just iterating on what we already saw. The performance, it is going to based upon your architecture that you are going to put on your code. So choose the right plan to minimize the cold start problem, or come up with some creative solution to keep triggering your Azure events even if you don't do that. So optimize your code for a smart catching of your API solution. If, let's say, if you are using an API data and how you are catching that information, so you can also think in that way. So that's how you can leverage some performance optimizations and cost optimizations. Definitely, this is only pay for execution. That means also on free versions of Azure serverless functions, you get 1 million of resources for free, 1 million of serverless functions hit for free, and keep monitoring your usage of however you are doing this. And also remember whatever the regions that you are deploying your functions on. Let's say if you are deploying it in West US region, you will be charged a different rate. If it is a East US region or Central US region, there is a different rate. So keep playing with that if you want to get the best rate out of possibly doing this. Security is the most important thing. This is like when we are storing our Azure OpenAI Foundry keys, then we found out that we don't want to expose that externally. So we started using our key vaults, where we don't expose our keys even in the environment variables or anywhere. So we started using some key vaults and best API management practices, something that we learned there while we are implementing some security there. All right, these are some ways that you can start. This is from my Visual Studio. Like these are the two trigger, there are many trigger types, but these are the two trigger types that we previously covered, the blob trigger and event grid triggers. So event grid trigger is something like a gateway. Whenever there is an event that is happening on a blob or on a notification or something, that will be triggered. But make sure this is the naming convention that automatically the Visual Studio will give you a template, but you are good to change that naming convention. Once you publish that function, you will see the same name, event blob trigger. So that is how you match that. You can play around with that, but it is good to have some good naming conventions on this event grid triggers or any trigger naming or function naming there. And in the same way, it goes for blob storage trigger. Once you select the blob storage trigger, the good thing about Visual Studio is it automatically generates a template for you, and all you need to do is run your code there and give the values of whatever the name of your function name that you wanted to give, and whatever the container name that you are trying to give. You can pass them through your variables or some environment functions there. Again, once you publish this function, on the Azure side, you will be seeing the same name like blob storage trigger, which actually gives you the confirmation that your function has been successfully published. All right, this is something new. Previously we tried to implement OpenAI keys directly, but we don't know what OpenAI is trying to target or train our data on. So then we have shifted our focus to Azure AI Foundry, where you can put your safety guardrails of whatever your internal teams or whatever your teammates are prompting about. If there is some sensitive information that they are trying to send out, you can put a block there using the safety guardrails function here. You see the safety guardrails function? Yeah. So that is how you can generate or deploy your model. They will provide you an API key, and all you need to do is, as you are using your OpenAI API keys, just call that API key and the inference endpoint there, and you are good to go. And you can deploy multiple models, large language models. There can be DeepSeek, Mistral, I think Gemini is not available. Gemini and Claude are not available on Azure AI Foundry. Only GPT, Grok models are all available. So that's it. And also the cheapest model on for the GPTs is GPT-4o Mini, which is costing us 15 cents per input tokens and 60 cents per output tokens, which is a great cost there. But I'd like to leave you with my last 2 cents here. When to not use serverless functions? When you are having some high compute tasks and long running processes and some memory intensive workloads and very slow operations, please don't go for Azure serverless functions. So this is something that I wanted to leave you with. But when to use, when is the best case to use Azure serverless functions? When there are some short-lived tasks like my HTTP operation of hitting a point, hitting an execution, and to generate a document and communicating with Azure OpenAI keys, that's where I will use it. And background jobs where there is no requirement of human handling these services, so please go for it. IoT data processing, so think that you want to send some car analytics like how Tesla does that, when you go and park that in your home, it automatically sends all the information to their central cloud service. So that is how you can do that for your car as well. And real-time stream handling, like how this current operation of live is getting streamed online. So that is the best use case for Azure serverless functions. So that ends my session today. Please feel free to ask any questions.
New learnings, right? A lot of good things, right? This is my second year. This is the second year for Commit Your Code, right? Last year I also spoke at here, and today we're going to be talking about predicting the future of equipment using ML.NET. My name is Ron Dagdag. I am an R&D engineering manager at 7-Eleven. I am also a Microsoft MVP. I've been with a Microsoft MVP for almost 10 years now, right? AI, Windows development, Internet of Things, stuff that I really enjoy, mixed reality and all these different things. All right, let's get started. Of course, who among here are machine learning practitioners or have worked with machine learning? So we have a few people. So if there's some questions about machine learning, we have some that we can help out. C# developers. All right, you got more and more people. Yeah, all right, that's good. Thank you. Any maintenance personnel? Because we're talking about predicting, right? Prediction. Okay, so we have that. Fortune tellers. All right. Since we're talking about predicting the future, we're going to talk about fortune tellers. Of course, has anyone heard about this crystal gazing? Of course, that's what this crystal ball is. Sorry about my crystal ball here, and we'll see. We'll work on it later on. Okay, so our agenda today is we're going to talk about predictive maintenance, and then what is machine learning, ML.NET, model builder, and then we'll do a little bit of demo. Okay, what are the different evolutions of maintenance strategy? Most likely you've worked with, if you're more DevOps or SRE, or you maintain applications, you deploy it, and then of course something goes wrong, you become reactive to it, and then of course as evolution goes, we have some more logging and all these different things. We become more preventative, right? And then condition-based. There's a certain threshold when you deploy it in the cloud, and then you have some monitoring. If there's a certain threshold that it meets, like let's say, it's not serving your customers, or in terms of the machinery, it started working or running, and then it didn't, it hit a certain threshold, and it sends an alert, right? And then, of course, now we're moving into these generation of predictive analytics, right? We're looking at the set of data, and from this set of data, we're trying to identify, oh, is it going to fail or not, right? So those kind of things. And then in the future, and that's where we're kind of looking at in terms of the maintenance strategy, is more prescriptive, like be able to use a lot of these AI tools to be more prescriptive on terms of like, hey, how we can proactively fix and figure out the root cause. Today we're going to talk about the predictive side of things. Okay, so just to visualize it, if you're working on a certain threshold, it'll go through that, and then if it's predictive maintenance, it'll be with all the different data and trying to understand a certain set. So why would you want to do predictive maintenance? You predict before the equipment fails, or when the equipment fails, ways to take care of the machines, to keep it running smoothly. Of course, a lot of great things in terms of that. So, but before I do that, I'm going to talk about some machine learning concepts, because I've heard there's only a few people that may have been not familiar with machine learning and all these, right? So a lot of us here are programmers, right? Yes? So you've seen this, right? You had to have your input, and then you write the algorithm, and that you get the answers. Like if you have a calculator, right? We know how to calculate, add, subtract, multiply, divide, and of course you have your input, and then you have your answers, right? Machine learning, it's kind of flipped. So you have your input, then you have your answers. You got a lot of examples of what the answers look like based from the input, and then what the goal of the machine is to learn the algorithm, right? To learn and produce in what we call a model. So in machine learning world, programming on the right side, and then machine learning on the left side, right? And how are they connected to each other? In machine learning world, input is training data, right? You need lots and lots of training data, and you feed it into this training framework. ML.NET is also a training framework. And then you go through this algorithm, and that's what we usually call the model, right? GPT is a model. There's our foundation model. There's different kinds of model out there that you can use this. And then now, instead of the algorithm, you replace it with your model, and then you have your input, your model, and that's what we call inferencing side. So on the inferencing side, you need an inferencing runtime. ML.NET is also an inferencing runtime, and then it's a loop. So if there's anything that you want to take out of all these presentations, if you understand these, you know when to use when, right? When do you need to learn about creating the model, building the model, or using the model into your application? So of course, model development, there's a lot of stuff, right? So it depends on what you're trying to do, right? So if you're doing classification, you need tagging data in order to create your model. If you're doing object detection, computer vision, object tracking, action recognition, different set of data that you need. Tag data, training data, that's fully annotated in order to create the model. So that's where ML.NET comes into the picture, right? If you are a .NET developer and you want to learn about machine learning, being able to create applications that can be run online or offline, right, or on the cloud or on the device, you can generate using ML.NET. It is a it is a training pipeline, so you can create the model, and also you can import existing model and convert it to Onyx. You can read Onyx models or TensorFlow models, and then of course it's cross-platform. It's Windows, Linux, and Mac OS. So ML.NET also includes AutoML. AutoML is something that accelerates in terms of training new data. So for here is an example. We're trying to figure out a taxi fare for one passenger from airport to downtown, right? So what does a machine learning engineer does, right? So it figures out based from the data, what is the input. So in this case, hey, there's car type, distance, passengers, and all that. Based from that data, it'll pick the right, training algorithm, right? So it picked this one, gradient boost, and then each algorithm will have all these parameters, kind of a way to tune it to be able to train a model, and then evaluate that model. Will give you a 30%, for example, accuracy rate, and then it goes to the next one. We'll figure out another one, and now it's better accuracy rate. It's 50%. And then you train another one, different set of features, different set of algorithms, different set of parameters, until you get to a certain point that say this model makes sense for this data set, right? You with me? Yes? So that's what ML.NET does, and also AutoML does. Based from that input, it would generate and find the best model. They would train the best model that you can use, and what is the optimized way to do that. It can also do explainability, which ones of your input has the higher importance as compared to the other one, and then you can start comparing it with all the other ones. So ML.NET has a called Model Builder. Model Builder is a UI tool that's inside Visual Studio to help, especially for the ones that no background in machine learning, but wants to learn the concepts of it, and also the same way integrate it into their application. So you can run it locally, you can train a machine learning project, or you can train it in Azure if you want to, but it always generates a custom machine learning model based from the training data. So 4 steps: you import the data, then you train the models, then based from that, you evaluate what does it look like, generate the code, integrate it to your application. Clear? Yes? Okay, so we'll do that. So of course, there's different types of problems that ML.NET and AutoML can help you. One is data classification. When you're trying to classify different machine needs, value prediction, you can do forecasting, you can do recommendations, right? There's a lot of different things that you can do. Classifying images, and also object detection, right? So today, I'm going to focus on data classification because that's the easiest one that I can get everyone to try out. So classification looks like this, or this one is more regression, or this example, but my demo is going to be classification. So you remember, there's got to be features, and then at the end, you specify what label, what you're trying to predict. That's your label, and then of course your data set, and over each columns. If you're familiar with Excel, this looks familiar. As long as you have features and labels and columns and rows, yeah, you can do this. But okay, now we're on the demo. But before I do a demo, we're gonna do. It's always good to pray for the demo God just in case. But you know, our Wi-Fi is strong, 200K API. At the end, in open source we trust. Cool, clear? So let's get started. All right. So of course, since I have my what you call these, my crystal gaze, or I want to make sure that is my demo going to be good. So. Oh, no, definitely not. I'm going to try this again until I get to say yes or not. But my demo is going to be great. Oh, points to know. So we'll know more. I prayed to the demo gods. I have my crystal ball. When the time is right, bro. This is the time. This timing is right. Okay, we'll do that. All right, so let's go to our Visual Studio. Okay, so if you're actually Visual Studio 2026, there's Insider Edition now. If you want to try it out, it's free. Try it out. It's something new. So if you're looking forward to this, but of course I saw it this morning. There's an update for the ML.NET Model Builder 2022 extension. So you can install this extension as part of your inside Visual Studio, right? And then this ML.NET Model Builder allows you to be able to say, I'm going to create a code. I can right-click on my solution. I can add, and then machine learning model. It adds that machine learning model capability. And I already did that. So it will ask you a few questions. A lot of us here, anyone here is visual learners. I like visual. I like seeing things because, you know, and take me with the one step at a time, right? Because that's how I learn faster. So in this case, we're going to say data classification, right? And then we click next. We go to environment. Where am I going to run it? I'm going to run it in the cloud. I'm going to run it locally. In this case, I'm going to run it locally on my machine. Next, what is my set of data that I'm going to be providing here? I have this CSV file, and the CSV file looks like this, right? You have your different data set, but I have my label. The label is machine working or not, right? So that's just a Boolean, right? So what you do is you specify which column do you want to set the label. So in this case, machine failure column. So now I have the set of data from my CSV file. This is the set of data. I'm going to identify what type of data are they. Are they a feature or a label, right? So in this case, the machine failure is the label. I specify it is Boolean, and it's categorical. Let me specify that. And then I specify, okay, this one type is a string. Feature is single. That means it's like a number, right? It could be a floating point number, or it could be a number, any number. And same way as for each one of these. And there are things that I ignore. I don't want to include this one. I don't want to include this one. I can ignore them. And also I specify them as categorical. So if I know it's string, but it's a category, so like product type or certain type, I can do that rather than treating it as a string itself. It would help us with the data set. And of course, validation data. Usually you split your data to like maybe 80-20. That means 80% training data and then 20% like to evaluate. But there's also a way you can do cross-validation. It requires a little bit more, but it splits the data into where it's not just 80-20, but it's like 5 iterations of splitting your data. So that makes it, you know, the output better. Then we do some training. There's different types of trainers, and you can specify how long will it take. So you don't want to take forever in order to run this. You can say, depending on the number of set of data that you have, you can run it, you know, 1 hour, 5 hours. It runs locally in your machine, but if you can also run the cloud. But give it a deadline, right? Just like any project out there, there's got to be some stopping point where we want to say, this is where we evaluate. Then there's also different optimization metrics. You can read more into these, what makes sense and what makes, with your data set. There's different trainers that you can use. There's, parameters that you can set for the ML.NET trainer. And then you can say, click training, and it will run for 60 seconds. And then what it'll do, so let's see if we can run it. So we have time. And look what it's doing. They're trying out different models in real time. Right now, there's like 10 models that are already tested. It took about 10 seconds, and it's the accuracy. It's picking up the accuracy. What it's doing right now, it's trying different types of models with different types of parameters, and then testing that model and getting the accuracy. So if you're doing this manually, you have to pick which model, parameter, train it with this data, evaluate, train, model, evaluate. But this one, it's doing it automatically. It's in automated fashion, and trying to figure out which one's best for your data set. Of course, right now it's like GBM binary, but there's different types of these models that it can be trained on. It's running it locally on my machine. So for the data set like these, you can run it locally. You can even try it out before you even, if you're doing proof of concept, before you even send it to your data scientist to analyze it, but it gives them a starting point. It's like, this is the best model that my data was tried with. But we can start there. We can do our testing there, right? We can evaluate. But after after some time, it gives you accuracy data, then you can evaluate it, right? So this is my input, and I can click predict, and there you go. It gives me the output, right? It gives me the data. What I do, I can try it out. So I can say, of course, I'm going to do a high number on toolware. Now it's telling me that it's 50% likelihood with this combination that it's going to be a failure, right? Based from the data set. So there's a lot more things that you can try, but it tells you like what are the likelihood of it failing with this set of parameters. So if you think about that, you have different parameters on your data set, different data that you look at on your machines, and then be able to. And then after you evaluate, and you think, hey, this is good enough, I can try this, then I can create a console app based from the data that it built. So we're going to try this and say we're going to create a console app from scratch, or you can even make a web API, but just to make sure that everything runs locally in the simplest case. So it generated this console app. It actually created this MB config. It created, this is the model that it's including in my application. It tells you how to connect with it. But if you look at program.cs, so let's do that and see if I can make this bigger. Control. Anyway, and if you can see that, it tells you right there, how do you use the model, right? I pass in this data from this ml1.model input, builds the model, and then you can just run it. Let's try that. Make sure it's good here. And click run. Okay, this is where. There you go. So it did run. Okay, the outcome cannot be predicted. Okay, so this one right here, it says predicted sentiment is false. So with this data, so now it is a console app. You can start incorporating into your application. And then you can iterate from there, like which item that I need to include and which one I cannot. But you already have a machine learning model that can be integrated into your application, .NET application, and take it, demo it, and show it to the world, right? To show it to your boss, and that would, that would help you. All right, isn't it clear? Isn't it interesting, right? So in a matter of minutes, what just happened, right? We trained a model, we incorporate it to a console app. that is ready to go to be able to integrate it with our application. You can run it in the cloud. You can even integrate it to your application. Cool. So I have some screens there. So, of course, it's not going to show. All right. So in summary, there's predictive maintenance, right? Predicting before any equipment fails. And then there's, we talked about machine learning. We talked about the difference between training and then the inferencing side. We talked about ML.NET, how does it affect .NET developers? What is it for .NET developers? We talked about AutoML to make it easy for us. We talked about ML model builder in order to generate custom models inside Visual Studio. One thing I didn't talk about is you can integrate it also to your MAUI apps, to Android, iOS. So it's cross-platform right there. And it allows you to be able to do that. By the way, my name is Ron Dagdag. And if you can, connect me on LinkedIn. Feel free to connect me. There's a QR code right there. And if you can leave me a review or provide feedback, the bottom is the connection to our agenda so that you can provide feedback. I really appreciate that. Do you have any questions for me?
Is possible to add any set of layers and the actuation functions into the model?
Yes, yes. So it iterates that. Depends on the model that you're trying. These are traditional models. It's not like GPT or it's not the large language model. These are traditional models that you can create for data classification. Yes, it does that. Yeah. Any other questions? Yes, sir.
Yeah. So what's kind of like the main difference between this and like using like an MCP server that has access to like whatever data set you have?
Right. So MCP server, it's more of like kind of API and how you would connect to a large language model that you can feed into a large language model. This one is for traditional machine learning models, like I was showing the data classification, computer vision. There's a lot of different models that's simple enough that you can integrate it, that does not need a large language model in order to be effective, right? Because it adds complications. Sometimes the simplest thing can fix the job, and that's what you want to look for as an engineer, right? Overcomplicating things, and maybe it's one of these is what you need, right? Maybe it's one of these: classification, object detection, action recognition, which is what is important. Any other questions? Yes, sir.
Ron, that demo was the smoothest demo I've seen all day.
Thank you.
What are some of the issues you run into
Right.
when you're normally building these models?
That's good. What are the different issues?
Yeah.
I mean, training data, right? Yeah. Do you have enough training data? That's what you need to. Any machine learning model, right? If you want it to be effective, how much data you have? But you can connect it to SQL Server. You have an CSV. Try it out there, right? Start with something, right? Start with something. Start with integrating this. And the interesting part of this is it can be incorporated into your application. You can revise it, right? And it doesn't require us to, hey, I need a data scientist. This one does not require us a data scientist. If you know how to evaluate, and if it's good enough, right, it's good enough, right? And what does the business need? Sometimes it's good enough. It doesn't have to be perfect. And that's what we're here for, right? Yes, sir. Large data, you can run large data sets. Of course, there's limitation. You can run it locally on your machine, and all these, of course, complication, right? So there's ways on, I don't know if I have this here, but you can run, so for example, if you have this much data set, right? You have 1 gigabyte of data, most likely it'll take you about 3 hours to do some training, right? And what makes sense, right? And sometimes if it's a computer vision task, you might want to, do it in the cloud, right? So like for example, there's instances where you can run it local GPU, or it makes sense to run it in Azure and all these. So there's different, of course, parameters, and it depends on what you're trying to do. Sir.
What would you suggest for folks looking into that are interested in like how we capture data from the equipment?
How do you capture data from the equipment?
Yeah, like what sort of technologies would you recommend
That's when it comes to IoT, right? So how do you connect IoT to send data to the cloud and then collect that information? And if you were in the previous talk, Azure Functions is another way to connect to your IoT and process that data to incorporate it to your database, right? So that's one way. If you got streaming data or however you get that data, or you can just do a batch, right? I remember I used to work for an elevator company. Okay, elevators, they're not always connected to the cloud. So what do? They upload the CSV file. Whatever that machine log is, whatever telemetry data you have there, then you process it in the back end, do all this stuff, right? So, and then you can have a model specifically for a certain elevator, right? You can incorporate AutoML into your CI/CD builds and those kind of things, right? Any other questions for me? Cool. All right, thank you very much, everyone. Yep, thank you.
All right, we have Bobby Ray Jr.
Give me 1 second because the monitor is like crazy big. So hold on a second here. Scale this down. We'll figure it out. All right, turn it on. All right. Can you hear me, everyone? We good? All right. So my name is Bobby Davis. I'm from Coder Foundry, and we're a coding boot camp. We teach people .NET all over the country. We also do training for corporates and also run a consulting company, and we build software for a lot of people. Lastly, I can't mention the company name, but they do $97 in tree bills a month. So it's a pretty big company. And one thing we run into, the most important thing that I think everyone needs to learn about, if you're aspiring to be a web developer, you're writing code, you're building websites, you need to be able to do 3 things: stand up an API, consume an API, and work maintenance on API, whether that's with PHP, Laravel, Java. I happen to be in the C# land. And so Microsoft has some great things coming out. .NET 10 will come out next month. It's in RC1 right now, and so the big talk in RC1 is, and at .NET 10 is about minimal APIs. But one of the things when you talk about minimal APIs is you get this. You go to Reddit and you say, hey, should I really get into this minimal API thing? And this is what you see. You see an example in Program CS, and Microsoft comes out with this fantastic example where they shoved 16 endpoints in one file, and everyone thinks like, yeah, we're not doing that. Like, you understand? I read these in Reddit, like, we have 1,000 endpoints at our company. There's no way we're going to put 20 engineers on one file. The merge complex would be crazy. We can't do that. And I'm screaming at Reddit, which, has anyone ever screamed at Reddit? It's like, dude, no one's working in one file, but like, that's what these people think. And so they'll say, and you'll see this, you could probably search it up right now, it's great for demos, it's not for production. And it's hard to test, and it's hard to scale, and no one's using this in any shop in the world, which is completely inaccurate. Like, people are using this a lot, and they should be, and we're going to talk about why you should. But imagine if you went to a job interview, right? And they asked you to like refactor a Java to a C# thing. They said, can you make this optimize and put it in C# for us? We're going to optimize our whole code base. And you get this take-home test. And on Friday night, you realize, man, they gave me the whole GitHub repo. I mean, the entire thing. And you rewrote their entire legacy system inside of C#, had it working perfectly, and you're going in on Monday, and you show up like this. You got this giant chili stain on your shirt, They ask you, say, can you give me like 3 prime numbers? Can you write an algorithm to give 3 prime numbers? And you said, I can do you better. I can give you the top 7, and in 2 minutes, I'm going to find a brand new one. I'm going to win a Nobel Prize today. You know what they're going to say? We loved your work on the legacy platform. We loved that prime number thing. That was a great trick. That chili shirt, though, we're just going to look in another direction. And that's the problem with this, is that there's perceptions with this. And the perceptions is the name of this thing is called minimal API. And Microsoft, if anyone around Microsoft a lot, you really do stuff a lot of it, they name stuff great, right? I mean, they're just good at naming things, they'll jump numbers on you, and I was in a GameStop several years ago, and there's this family and they're trying to buy an Xbox for their son for Christmas. And they were saying, should I get the 360 or the Xbox One? And I hear them talking about it, and the dad saying, 360 is better, right? It's a bigger number. Like, it's a bigger number, and I'm standing behind them, and I'm like, all right, you know what? I said, I'm going to save Christmas for people today. And I went in there, and I was like, I know it's a bigger number, the one's newer. I know it doesn't make sense, but get the Xbox One. Trust me on this. When your son opens an Xbox 360 for Christmas, he ain't gonna like that. He's gonna shoot Santa, but get him the one, right? So this is the problem we have, is that minimal seems like it's limited, like it's lesser than what MVC controllers are, or lesser than other platforms out there. We're just doing the bare minimum, and it's not really that. And they compound this when they give you an example, and like they shove everything in one file, and you're like, dude, that's not the way this works, And so it creates this bad first impression like a chili stained shirt. And these first impressions tend to stick around. So when we talk to customers, I always get this feedback. They're like, yeah, minimals, really? That's what we're going to do? I'm like, yeah, there's a reason, right? We'll talk about it in a second. But going back to game stuff, I always wondered, like, that kid at Christmas, and I saved his Christmas, you know, what did he turn out to be? I always wondered, did he start a conference or did he like do something really big? You know, I always wondered if that ever happened. But maybe it did, I don't know. Some people start conferences, I save Christmas. They may not be equal, you know, but Christmas is better. But we need to talk about why minimal APIs. Well, they're lightweight, and when I say they're fast, they're blazingly fast. Like, it's really quick. In fact, if you're running in Azure right now and you have an MVC controller and you just replaced it with a minimal API, peer-to-peer, no enhancements, it's going to use less memory at startup. It's going to start up a lot quicker. It's just faster. It just is. If you're coming from something like Node.js and going to minimal APIs, it's not even in the same ballpark. Now, it doesn't really matter for most projects. But if you're transmitting $97 trillion worth of T-bills on a monthly basis, suddenly, you know, you have to look around and try to find the points you can. So this is blazingly fast. The biggest thing about this, and this is the pattern from Blazor to APIs, is that they're being very pattern agnostic. So where MVC said, you got to do it this way, and this is my way or the highway, and you can't do anything different, and people are like, well, I don't want to do it that way, so they pick a different framework. And now with Blazor and with minimal APIs, you can pick whatever pattern, how you want to do it. And because it's pattern agnostic, they throw out a simple example and they just shove it in Program CS, and everyone goes, can you just tell me how to do it? And you're like, well, I thought you wanted us not to tell you how to do it. So like, I can understand where Microsoft gets a lot of hate for this. The biggest one here is that minimal APIs don't include a view engine. So with MVC controllers, you get everything, and that's the great thing about MVC controllers. The bad thing is you get everything, right? So it's slow startup. You get a view engine, you know, it returns a view. You don't get this. This is API first, and then you can start small and you can scale your structure up. You can start in Program CS, like this sample is, or you can go all the way out to some stuff we'll show you in a second. And you get the full .NET, DI, dependency injection, validation, which is new for .NET 10, Open API, we'll show the documentation, and then AOT, which is ahead of time transpile. So that's really, really where you get your speed from. You don't get this inside of this. So let's look real quick here. MVC, full web stack. It's got some scaffolding, makes things cool. Super heavy if you're just making an API. Minimal API is lightweight, high performance, pattern agnostic, full .NET. Has less scaffolding, a lot more code for us to write, but you get the trade-offs there. And then simply, if you're looking at JS backends, they're a little bit slower and they're dynamically typed. You don't have something like C#. But, you know, let's look into what we could structure this as. So the big thing that we want to come away from here is we want to remove these get, map.get, map.post, map.whatever inside of Program CS. We want to move them somewhere else so that we can keep our Program CS kind of clean. And this is a simple structure I could come up with without going into any specific pattern. So if you don't like this pattern, I hope what you can take away from this is do whatever you want. Do it however you want to do it. I'm just going to show you the magic here. And the real magic is we got to run an extension method. An extension method allows us to group endpoints and map them. And this is what you find programmers yelling at Reddit is like, you guys know what an extension method is? It's been around forever, right? And so like, but a lot of people, when I talk to them, they don't know what it is. So we can make our endpoints live outside of Program CS, and we can group them by feature, group by domain, you can group a vertical slice, you can do a Reaper pattern, whatever you want to do, and then your Program CS stays clean and it's not in there like you want to do it. And to reiterate, you can group them however you want to do it. All right, so we're going to try to write some code here, but it looks like we're in like 480p over here. So I'm going to see if I can make this a little smaller. Maybe 50%, maybe something like that. Can we see that? All right, so this is huge. This is, we won't be able to see a lot of this, but I don't know why it's so big, but whatever. Program CS is our main entry point here. And you can see here, even today in .NET 10, this is Visual Studio 2026, and then I'm running .NET 10 RC1. So this is like the newest thing out there. You run the sample, and they still put your endpoints inside of Program CS. They even have this variable here inside of CSS or inside the program CS that supports this, and even have a record down in here too. So they just shoved all this stuff in here, and if you're like, you can't write code that way, and that's true. So this is the magic here. So we have, here's what's called an extension method, and this extension method allows us to group endpoints. And so if you look at here, this top here, the reason this extension method's static and it's public, and it participates in this interface called endpoint route builder, which just means that if I pass it a route builder, then it'll take the routes that it currently has registered and append to them, right? And so that's why it's called an extension method. We can call this any number of times. So we can make a map customer, a map order, a map products, a map admin, whatever, and it's just going to attack all the routes on them and register the routes inside of our server for us. Now inside of here, we have some really, really kind of interesting things here that's going on. We can make a group, and here's where you see other languages you'll have a route file or something like that. We're defining here what is the base level route for all of these endpoints. And that could be all our gets, posts, puts, and everything. And so I have an API/customer route. This could be anything you want, and this is whatever you name it. And then, this is kind of cool here, we have add endpoint filter, and I'm going to try to show you that real quick. And this is one of the things that I did. I wrote another extension. This is like crazy. Let me get my arrow key here. And so we have this exception endpoint filter. I wrote another one that basically allows me to run the endpoint, and then every one of those endpoints gets pushed into this, essentially a try-catch, and I can catch server 100, server 500s right here. So I don't have to write a try-catch in all of my code everywhere. I write it in one place, and you can do this for anything. You can filter for 400s, anything that you want, special ones, 302s, whatever you want to do, and you can just pass it in here. And notice the other thing that I do inside of .NET here that I have is the ability to check the runtime environment, so that I can say, if it's in development, show me the message. If it's not in development, don't show the message. If it's in production, you don't want to leak out special information, stuff like that. So just another side thing. It's not really an API thing. It's more of like, hey, .NET's kind of cool. All right, so now that we have this here, I've got all these maps in here, and I know this is really like super big. I keep saying that, but it's really big. And I've got these, I got to get customer by ID, I've got to create customer, a post here, and this is just the declaration for the route, and I return this group, and it appends it. And down here, I made this look like a controller where I just basically put my static methods that does my business logic. I also have a service method here that does the ND framework calls. The reason we do that is because typically we're writing a Blazor app. Blazors have server-side components. We have an API that services the front end. And so our service layer can service the back end, and then we can still use it inside of our API endpoints. But however you want to do it. You could put all of your code right here if you want to do that, however you want to do it. This could go in a different file altogether. So when we run this, if I can run it now, where's my run? I'll just hit F5. If we run this, we can see kind of the, where's my F5? F5 doesn't work. Yeah. Where is it? We'll give up here in a second. Here it goes. All right, so it's going to go through a build, and I'm going to show you something else. There's also the Open API spec here that's kind of cool, and this is scalar. I don't know why. We're going to zoom down on this here. We'll try anyway. And you can see here I've got my endpoints in here, and I've got that weather forecast right here, and I can run this. And it tells me what I can do, and I can run a test request. And it'll come back with a response. I wish this wasn't so big, but command minus. All right, that's a little better. And see, this comes back and runs, and it's kind of cool, right? So what if we could get our customer endpoints in there? So we'll just write a little code here real quick. And we'll go through it, kill this. And from here, I've got this method here called map customer endpoint. And I can come in here now, because I can write some code in here, just app.map customer endpoints. Let's see, rebuild. This is just throwing me off big time. Good. And so now what we can do is we can look at it and see, now we have this customer drop down in here. So now I have all of these endpoints in here that are registered in there. So I didn't have to like change that it works, and I can run a test here. And this repo that you can grab will also create a SQLite database for you, so you don't even have to like do the data, it does all of it for you. And see, we've got these names coming back in here. And we also can kill this. We can run a get by ID. I can test this one. And this is scalar, it's kind of cool. But it's not cool when you have like 32 scroll bars going on. So, and we can send it a value of like, let's see, did I write the wrong one or wrote the wrong one? Yeah, value, where's my input? Let's do get by ID. Let's do that one first. Can't see it. And so here you can just run the ID, and hit 12 or something like that. It'll come back and run it for us. So now it's that hand shoe list. So the other thing that we can do is we also can show you real quickly how to like, where you would enhance this, where you'd write your actual code at. And you can see I've got my groups here, and this is going to be exceptionally hard, but that's all right, we can do it. And here I've got this throw not implemented, so what we can do is we can just write var, something like created customer. Let's stop it first. Kill that. But this is where you would write your code. Something like this to rerun the method here. So it's pretty simple for us to do. Equals, and then wait. The thing I'll notice too, for free here inside of .NET, also these cancellation tokens, which are really cool. If you have a long-running process, an API, or you can pass it a cancellation token, it automatically takes care of that. It knows that the user's closed the browser or whatnot. And we could return a typed result. Usually I get Anyway, I won't bore you with the demo. We'll go forward in a second here, but in general, you can key takeaways is that you can have a naming and examples, give minimal APIs a bad impression. The structure and the extension methods unlock the scalability. So if you can just write the extension method, you can group them however you want. You could bring a Reaper pattern, vertical slice, repository services, whatever you want to do. Built-in validation, DI, Open API, AOT, full .NET, and it's lightweight and it's extremely quick. So if you're looking for performance, minimal API should be on your list. If you're looking at a .NET project today and you thought you were going to write it as a controller backend and you're not using MVC, then API should be the thing you pick at this point. So anyway, with that, we can stop and ask some questions. sorry for the 480p monitor there on my, I don't know what that deal was, so couldn't see it. Any questions? All right, well, I ended 5 minutes early, so appreciate you guys. If you want to reach out to me, you definitely can find me on Twitter, and you can find me on LinkedIn. I'm also sometimes on YouTube, so I have a YouTube channel, so just take a look up for Coder Foundry, anything. I'm usually around there, and that's my Twitter handle if you want to follow me there. All right, appreciate it. Thanks for your time.
Everybody can hear this? Perfect. All right, guys, we're going to go ahead and get started. My name's Alex Johnson. I'm a software engineer here in the DFW area, but more specifically over in Fort Worth. And I work at a company called Sustainment. We build software for manufacturing companies to strengthen their supply chains and get procurement work done better, faster, easier with AI. And today I'm going to be talking about a topic that's dear to my heart right now, because when I transitioned to this company from my previous company back in the beginning of 2024, I actually had to make a transition on some tech stack stuff that I knew versus what I had to get going on in that new company. And so for a long time I was very into React, still am, but it was my main framework of choice. Didn't know anything about Angular, and when I got this job, I had to very quickly get up to speed on what Angular was all about, how to use it, best practices, all of that. And so that's kind of what inspired this talk. And so I'm going to go ahead and, I'm going to show you guys a little bit about that journey for me. So a tale of two frameworks. You have React, you have Angular. There's some other ones too. I think Vue is amazing, but we'll leave it out for now. Because these are kind of, these are still two of the biggest ones that everybody's using, right? And so my experience, like I said, was in React, had to move to Angular. And so for me, I had to figure out what is the quickest way that I can get going in this new framework so that I can hit the ground running on day one. Because you never want to be that person that goes in and you're starting on day one, day two, and you're like, I have no idea what's going on. And it takes you an additional month, 2 months to get started, right? And so this kind of inspired this talk to be able to share, what are some of those things that I did to figure out how to work in Angular as quickly as I possibly could, so that when day one came, it was almost like I knew exactly what I was doing, which I did not, but I was closer than I could have been. The other reason that I decided to do this talk too, and I'm sure you guys have seen this, especially if you're on any social media, particularly LinkedIn, there are framework wars out there. Okay, there are people that are very highly opinionated about what frameworks they like using, which ones they don't like. And for me, it always kind of drives me crazy when I see people talking about, especially negative stuff about frameworks, because they all have their strengths and weaknesses. And there needs to be more love, in my opinion, right? And so the other goal of this is to show you guys really actually how similar React and Angular are, okay? Because there are similarities and differences, but when you look at them at a real core fundamental level, they aren't as different as you might think. And then they're always evolving and changing. Obviously, Angular has more frequent releases than React, so it's changing at a little bit of a higher clip, but they both change. They both evolve, they get better, and so keeping up to date with them is super, super important. And I just had to, because I've been doing this recently for other parts of my life, but I had to ping my friend Claude and come up with a good punchline or tagline for this whole part of the presentation, which was, what should we be saying about framework wars and relating the two? And so here's what Claude came up with. Don't let framework debates make you Angular. Just react with kindness. So hopefully by the end of this talk, you guys will feel a little bit more that way. So real quick, before I dive into the code, if you want to, you don't have to do this now, but if you want to, this is the repo that I'm going to be showing. You could pull it up on your phone. You could also save it for later to check it out. So all this code you're going to see, you actually could look at it at a different time. I'll give you all a second to do that. And then I'm going to close this out because we're going to dive in here and I'm going to move over. So what I decided to do to sort of show this off, to show you guys the differences in the similarities, is actually build an app. And I'll be honest with you, it's not the most beautiful app. And actually, I even had Claude do a lot of the styling just to save some time. And you'll see that in a minute. But it's a basic weather dashboard. You can put in some coordinates and get the weather data for that city, right? And actually, this API we're hitting is just literally weather.gov. Super easy API to hit, it's free. It's literally, like, if you go to the weather.gov website, this is what they're using. You can even see the same images and everything.
So I decided to build this application in both frameworks identical, which you don't see a lot. A lot of times you'll see on the internet, people are comparing the two, and they're like, oh, well, here's React, here's Angular, but they don't ever show like an exact same application in both and what they might look like. And so as you can see, here's the React one, here's the Angular one. They're the same, right? No difference, at least from this perspective. We'll see little differences in the code. And so what I wanted to go through quickly here is sort of point out some things about each framework that kind of make each framework what they are. But before I do that, just a quick poll. Raise your hand if you feel like you're pretty proficient in React. Okay, a couple of people. How about proficient in Angular? All right, how about both? Okay, so and then we have some people that are like, I literally, what one of my old teachers used to do when I was in school is they used to say, raise your hand if you didn't vote. Everybody do that. Now you did. Haha. Okay, so I'm going to show you a couple things to kind of point out really where some convergences happen. So the first one is we can actually look at where the app gets instantiated for each framework. And so right here we're looking at the React app that you saw. And every React app has a file where we create the root, a little bit bigger. Mark says bigger. This TV is a little small. Every React app has a file where the root is rendered. So for a single page application, you have a bare bones HTML file, right? And then all the code gets injected in. And so right here in this div, that's the root, that's where the whole application gets injected. And so this code here, that's how that's happening, right there, okay? And then guess what? Interestingly enough, in Angular, it's really not all that different, okay? We have a root, okay, and it is a little bit different here the way that it's set up, but it's there. And then in our main file, we have a function that is instantiating that as well, okay? I'll have to blow all these up because they were all minified. Okay, so you can see it really, even from the very beginning of the app starting, it works essentially the same way, right? And then from there, each framework has its own way of having the initial component that you see here that renders the rest of the application. So this component here is the same one that we saw rendered right here. Okay, so in the React app, that's the app component, here it is, and we'll dive into a little bit of this more in a second. And then in the Angular application, same thing. So we have our root here, and then that component is here. I'm going to bring some of these down so we can see a little bit better. Okay. So a couple things to point out. When you get into these applications and they're starting up and you're learning them from scratch, you have to have some concepts that you're hanging on to be able to figure out how to use them and how to build things, right? And so for me, the first thing that I always go to is markup and styling, right? How do those things work in the framework? Because that's kind of the bare bones level that you can do. And so what I actually did for this application, and this is not necessarily common practice, but I did it here to show a point. This CSS file, I only have one for the entire app, for each application. It's just one big old long CSS file. And like I said, I had Claude help me generate this. But it can be used in one file if you want. Most people don't. You usually split up CSS into separate files. But I did this to show you that in this Angular application here, it has the exact same CSS file as this one here. Okay, it's the same thing. And so the CSS specifically, the styling, isn't necessarily any different between the frameworks. You can do different things if you choose, but you can also stick to basic CSS, right? I know in a lot of Angular applications, you'll see a lot of Sass or SCSS. That's pretty common. It can be common in React as well, but there's also Tailwind that people use, tons of different styling options. But just to show you that the CSS, you can do it however you want, no matter what framework you're in. And then as you saw here in some of these components, so like here's one of the React components. We are just rendering, at the end of the day, HTML-ish stuff, right? Now this is in a JavaScript or a TypeScript function, and you know, this for React, this is known as JSX, but it is, at the end of the day, it works the same as HTML with some differences, right? And then over here, we have that same kind of thing in Angular, right? So we have HTML, but in the Angular template, it's not just HTML, right? There's other things in there that make it different so that you can do more powerful things. And so starting just from those two areas, that already cuts down a bunch of the, I think, some of the fear that somebody might have of learning a new framework, because a lot of this stuff that we're working with is already the same, right? From there, what I usually like to go into and try to master is looking at application state, and particularly local state. Okay, so in React, we have what are called hooks, which for those of you who have not used React before, it's basically a way to manage what the application looks like or is functioning like at any point in time. So for this particular state here, we have this show Celsius state, which is essentially over here in this part of the app, and I'll go over here. There's this little toggle that we have to change the temperature unit, right? And so all that this is doing is it's just saying, hey, we have a state, are we showing Celsius? And then here's a way for us to update that. So down here in the template, when we click that button, we're just changing it to whatever the opposite unit was, right? Well, this can look different in Angular, but really, it's not all that different. So we have over here in our current weather component, and actually I'm going to go over to right here. In Angular, we also have ways of setting state for our components, and the difference with Angular is that because it's been updated frequently and it goes through frequent updates, there's actually a few different ways that you can keep state in an application. Over time, they have changed, right? So at one point, we didn't have signals, okay, which are essentially really quite similar to like a use state hook where you can keep some state, you can update the state. Previous to signals, when they didn't exist, you know, you would actually set class properties to be whatever you wanted them to be, right? So you could have, and I put this here, the old school show Celsius before signals. So you could have it be, man, that keeps popping up and it's annoying. You could have it be whatever state you wanted it to start at. You could have a starting state, and then when you go to change the state, you would just change, you would set the class property to whatever that new thing was, right? The way that it used to work in Angular is you would set those class properties, but there was no inherent reactivity in those. Like when you change a property on a class, it's not just going to know to change the application state. And so Angular for a long time, and even some legacy applications still do use Zone.js, which is a library that's essentially tracking different user actions, things that are happening in the browser, and listening for has something changed or not. But the problem with Zone.js is it's only tracking if things might change. And it doesn't necessarily know exactly what's happening all the time. And so signals were a big upgrade to Angular because they are actually based on a true reactivity model. So this signal here, we're doing essentially the same thing we're doing here, except we're using this function, okay, which creates a signal under the hood, which is a whole other object. And then we're setting an initial value to false, just like we were doing up there. The difference now is we can update this signal actually quite similarly to how you would do it with a use state hook in React. So I'll go back here and show you, right here, we're taking the previous temperature unit and we're flipping it, right? Same thing here. Okay, the biggest difference between a signal and a use state hook in React is React exposes a separate value in a separate state updater function, whereas a signal actually has the signal itself. So you could call this signal and you could just read it. So you actually just call it as a function to read it, right? That'll give you the value. Or you could set a new value explicitly, okay? Or you can use update for taking the previous value and doing whatever you want to with it, right? But it's still very, very similar. And so for me, when I was learning Angular, that made it so much easier because I was like, hey, this works essentially the same way, right? And then another thing is, I'm going to show this real quick. In React, I'm sure everybody has heard of the dreaded use effect hook. So a use effect hook is a way that you can run some side effect outside of the render cycle that React has. And so right here, I'm just showing, we're just logging something out, right? So on the screen here, I'm going to show you when this starts up, it's only going to log one time, except, here, let me clear this out so you can see. So it's only logging one time this, hey, we're up and running. You can do that same thing in Angular, and it's not really any different, right? So if you go to the app component here, okay, Angular has lifecycle methods that work similarly to a use effect hook, but you can actually partition them out. So you could have, in this case, this ng-on-init hook is only going to fire after the component first initializes, but there are some other ones you could do things later. There's also an effect function that does, again, very similar to the React use effect where you can run some code in here. And I put a couple notes in here specifically about this effect here. Is how it's different is there aren't any dependencies like in the React one. So down here you can actually put in this array what dependencies are going to make this thing rerun. Okay. In this case I have none, so it's only going to run once. But in Angular, it's actually going to run any time a reactive signal is read inside of here. So this right here is a signal that's being read. So this will actually run every time it changes. But if you want to not do that, okay, if there's some signal you want to read it, but you don't necessarily want to rerun the effect when it's read after that initial time, you can use the untracked function, which essentially, like it says here, execute an arbitrary function in a non-reactive context. And then you could even return a value from it if you needed to get a value out of it. So this kind of works like inside of a React use effect hook, you could use an if block to check if something is the case and not run that effect. It's kind of the same thing there. So there's some similarities there as well. And then the second thing I wanted to point out, or sorry, the third thing I wanted to point out is actually let me start over here. In React, sometimes there are some variables or things that we want to read that are not necessarily going to be state that ever gets updated. And in React, that's pretty simple. All we really do is inside this function here, this component, we just create some variables that are based off of some other state. Okay, and we call that a computed property, right? So this display temp variable here is based off of this state here, which we know is a reactive state because it's part of a use state. And so this, we already know this right here will change any time that show Celsius changes because it'll re-render that component. Well, in Angular, we have a similar thing now where in more modern Angular, when we're not relying on Zone.js, we have other signals. Okay, and this particular one is called a computed signal. And it takes a callback function that reacts to any signals that are read inside of it. So we just looked at this one here. This was the display temp. Over here, we also have a display temp, and it is a computed signal, and it's going to rerun when this changes. So this current weather here changes, or when show Celsius changes, like we saw here. Okay, when that changes, it's going to rerun. Okay, so again, a very similar concept. And that really helped me to grasp, oh, okay, I know what's going on here when I'm building an application. Okay, I want to talk now about the concept of dependency injection before we sort of finish up here, because that's kind of one of the biggest things I think that differentiates Angular from React. And so in Angular, we have the concept of dependency injection where a component or a service is depending on some other thing to get information, data, whatever it might be. And so we actually have a service here in this component, which a service in Angular is essentially another class that you can use to do a bunch of different things with, but but more commonly you use it to have some kind of global resource that you need access to. It could be an API, it could be some type of global state. And so here, this service, the weather resource service, I'm using to get the weather data in this particular component. And so we use this, this inject function here to get that service so that we always have the most updated state of that service. And so actually I can even go here. Here's the service itself. Okay, and this is, it has the injectable decorator here, which is essentially telling Angular that this is something that can be injected into a component. And so inside here, we're using a couple new things that got released in Angular recently, some new signal-based APIs to do asynchronous data fetching, things like that. So this HTTP resource, we are actually doing a fetch to get the weather data. And then this here, we're actually, basically it's getting exported out of the service, right? And then, or sorry, it's getting used here, and then these public properties are reading from that resource. They're getting exported out of the service. And so now when we go over to our current weather component, we can actually use those things. So if we go over here, we have the, let's see if I can find it here. Yeah, so the current weather, okay, that's just coming from the service, and we're calling that signal that it's exporting. This concept can be a little bit daunting at first because, again, you're having to have something that's outside of a component, you're bringing it in and using it. Really and truly, in React, there actually is something similar, and people don't always think about it a lot. But in React, you can actually build your own custom hooks, which are essentially, they really are a type of dependency injection. And so what I'm doing here is I have this custom hook, and I call it use weather vanilla because I also have another hook I'll show you in a second that is the, I'm using React Query, which is a different version of it. But here, I'm accessing a store, which is some global state. I have a function to fetch the weather, all the stuff here to do that, and then we're actually exporting that out of the hook. And so I can actually go use this hook where it's being called. Let's see if I can find it. I think it's in here. Yep, right here. So here's the fetch weather. And so it's kind of like I'm doing a dependency injection kind of situation where I'm using that hook to inject something that I need, and then I use it, right? So a lot of people who are building React apps forget that they can build some really cool custom hooks like that, and so I do it all the time because it's very helpful. And actually, I can show you here. There's one that I did. I'll zoom in here. This is at a previous company, but we were using Socket.io to do WebSocket communication. And there's a lot that goes on, a lot of boilerplate that you have to do to connect to a WebSocket, and so put in a custom hook. It's super easy to use. So now here, you've got, all you do is inside the component, you just call the hook, you get the socket itself, you can put what events you're listening for, and it's a lot smaller and easier to use, right? In Angular, with the entry of, let me see if I can find it here. Which desktop did it go to? Oh, I have to zoom out some more. Woo, not that much. Where did they go? Oh, here they go. With the introduction of the inject function, you can actually kind of make your own custom Angular hooks, if you want to call them that, where you can actually inject some dependency inside this function, so not in a component. You can inject it in this function, and then you can abstract a bunch of logic that you want to do in here, so that when you use it in a component, you can actually just call this one function here and not all of this code in here. So again, at the company I'm at right now, we're using LaunchDarkly to do feature flag, you know, when we release stuff and we want to hide it in production until it's ready. Right here, I made a custom Angular injection hook, essentially, to get flags from our flag service, and it's super easy. So all they have to do now is just, in the component, you just call this, give the flag key, and then you can use it just like that, which is awesome. Okay, I'm going to wrap this up here since we're getting close to time. Let me go to, oops. Cool. So what now? If you're transitioning between the frameworks and you're doing one or the other, what should you do? Stick with the basics first, right? Some of the stuff I went over today, if you get that stuff nailed down, then you'll be able to get the rest really easily, right? And then lastly, check out some more resources. So if you're learning, do as many resource hunts as you possibly can. These are official doc links. The Framework Field Guide by Corbin Crutchley is amazing. I don't know if you've checked it out. It's awesome. And then a bunch of YouTube channels that I follow. Okay, if you go on this, and you can find those. And then here are all my socials if you want to reach out. My LinkedIn is there on the QR code. Yeah, awesome. Thank you so much for coming, guys.
Perfect. Hello, hello, everyone. Okay, that's what I thought. That's what I thought. I know it's 3:30 on a Friday, but I'm so happy that y'all are here. Welcome to Coding for the Senses, where I want to talk about a question that I've had recently about what do we do if we want to create experiences that don't just tantalize the 2D from what we can see, but what if we used all 5 of our senses? And in doing so, I created a little project, and I'm excited to share what my findings are today. So, does anybody remember when we craved most of the customization in our lives? It was digital, we had a MySpace, maybe we shouldn't have been on there in the 7th grade. Dad, you didn't hear that, but you totally did. Or it wasn't even just on the web itself, it was in technology that was actually physically cute. Like having your favorite color Game Boy or your favorite color physical computer. That customization that we craved is something that made us all unique and something a lot of us can relate to. Now, as time has moved on, in some ways we have started to morph and shift into each other. We all can look at our phones and see that they're basically looking the exact same, which is something we could not say 20 years ago. And all of us have basically the same ringtone, which is no ringtone at all because all of our phones are usually on silent. So, that spark and that drive that we had for customization previously, that is actually embedded in our DNA as engineers. And in the early days of the web, there were some extravagant sites where you could go and have a personal experience. Now, were these sites always accessible? No, they were not. But what they did very well is they pushed the limits of what was possible with what little resources they had. Now, as we have become professional engineers, I think a lot of our work has started to look a little bit more like this. This is a productivity app. It looks good, it's clean, it's professional, it's perfectly useful, and there's nothing wrong with that. But what if instead of just building the base of that functionality, we apply that same creative energy that we had in days previous or building those really extravagant, not accessible apps, and we brought those into today's day and age. So that's exactly what I did. Now, this is a little bit different, but what you see here isn't a difference in functionality, it's more so a difference in experience. So what this is, it's called Epic Endeavors, and for people who need a little bit of extra motivation to do your chores like me, it gives you that motivation to do so by making you feel like it's an experience. It still has that ideal productivity base of it, but this is going to tantalize your senses just a little bit more. And today what I wanted to talk about is how I unpack this application and how it really engages how you see, how you feel with sound and with touch and smell and taste as well, and we'll get into that a little bit more as well. So I want to start with the one that we are probably all the most familiar with on the web, which is sight. We have all felt and seen the limitations of the 2D world. Has anybody ever tried to buy any version of furniture online and you see it, you measure it 3 times and you get it and it is still too big to fit in your space? And you have to figure out if you want to send it back or if you want to keep it. That is the problem that we have as engineers. As we have started to perceive different experiences, as we start to see new experiences on the web, how we perceive and see them is changing as well. And that's the fundamental problem with our basic tools as web developers, which is HTML and CSS. Now, those were metaphorically created for our 2D document, but we need to move a little bit more into a different frame of thinking. So our technical problem as web developers, as React developers, is how do we go from building just flat pages to more immersive places? So we saw a couple seconds ago, this Epic Endeavors app that I built is a productivity app where you can list out all of the different things that you have to do for yourself for the day, and basically you can roll a couple of dice, Dungeons and Dragons style, we love it, to go ahead and decide what you want to do. Now, we'll see a little bit later in the talk, this is actually a full sensory experience. I was able to do this with the same tools that I'm used to using as a web developer, specifically as a React developer with a tool called React 3 Fiber. Now, how many of us are familiar with 3JS for 3D modeling on the web? Perfect, a lot of people. So I was a little bit intimidated to do this at first because I am no expert at 3D modeling whatsoever just yet. But I was able to use those web development fundamentals and also learn a little bit about 3D modeling to be able to create an experience like this without having to go spend a lot of extra time in school or a lot of extra hours somewhere. So React 3 Fiber is a React renderer for 3JS. And what you see here is basically a 3D scene. And this 3D scene is full of all kinds of individual meshes. And what we can do is use those building blocks with React that we're already familiar with to create scenes like this. So the foundation of any scene itself is going to be our canvas component. Just like in React, we are used to using a root div. For here, we can use a root canvas. And inside of it, we're not using any complex manual re-rendering loops. We're basically just declaring exactly what we want to see. So for the room that we have for the dungeon, this is very basic, just simple 4 or 5 planes, I guess. Now, these planes are considered meshes, and once we give them a little bit of geometry and texture, we basically have a room, and that's what it looks like. So the dice you see are also a lot easier than you might think. Was anybody also really bad at geometry? Because I know my grade said that I was not an expert at that. React 3 Fiber gives us a lot of great different helper libraries and tools that we can use, and this one in particular is called the Dre library. I will not disclose how long I took trying to build this. I actually don't even know what you call it. It is a very complicated, this 20-sided die. That's what I wanted it to be. Trying to get the geometry on that just right by myself was taking absolutely too long, but then I realized I actually didn't have to do it because there are helper libraries that are built in to do it. So what do we do when we want to spin these objects, or we want to have very granular control about how they move? We can also use a tool that is going to be, the use frame hook inside of both the Dre library and React 3 Fiber. So this basically gives us dynamic control over how things spin, how they react to physics, and it's going to run 60 times per second to really give us that fine-tuned control. Now, depending on what you're doing, this can be very non-performant, but thankfully this hook gives us cleanup and takedown as well, so we can be a little bit more performant about how we do it. Now, the thing is, we will not always be creating dice in real everyday life, but this technology has real and practical uses. So this is actually what is powering the next generation of e-commerce. So that furniture that we talked about a couple of minutes ago, it is making it easier for you to actually see it in your space before you make that purchase, even though somebody's going to tell you to measure it 3 times. Hopefully it will come and it will be the right size. But it's also revolutionizing education. When we think about anatomical and engineering concepts that can be very tricky, it's making knowledge like this more accessible and a lot more interactive. It's also transforming real estate. Who here has rented an apartment or even a hotel room recently without actually taking a look at it online? Nobody, right? For the most part, we want to see what it's going to be, and this allows us to do that from thousands of miles away before considering an investment. So by moving from just creating those flat pages, we go to creating very immersive places that we can take people to create deeper understanding, for greater confidence, and we're making knowledge a lot more accessible than ever before. So we've seen how we can build these incredible and immersive worlds, but the world is not just for looking at. It's for interacting with as well. And the way that a user interface responds to our clicks, our touches, our drags, that's actually very critical to creating trust and a sense of life within applications too. And that brings us to our next sense, which is touch. So I want you to think really quick the last time that you were going to make a little impulse purchase. Maybe it was a lot of money. You put it in your cart, you go ahead and click place your order, and absolutely nothing happens. We love that, right? You're thinking to yourself, oh my gosh, did it actually go through? Did it actually work? Is it thinking? You have no clue because nothing happened. Now, this is a lose-lose situation, not just for you as a consumer, but it's also a lose-lose situation for the buyer, for the company too. That little second that it gave you to think about whether you wanted that PS5 is enough for you to decide, I actually don't need it. So they've potentially lost a customer. Now, that amount of time that it took to not hear anything at all is a vote of no confidence that we're giving in that product. And it's a bad digital handshake. So this and responsive touches aren't just for decoration. Those little pieces of movement actually tell and convey to our users, we're listening to you, we heard you hit the button, and it's a handshake that goes back and forth. So the problem with orchestrating different things like this, especially in applications like React, The DOM wants, or React wants control of the DOM. Animation libraries want control of the DOM. So how do we create that handshake? And if we're not careful, what can happen is everything wants control and everything's going to be buggy. So that's why I have really been loving GSAP, which is the GreenSock animation platform, which is making animations a lot more easier and it's a lot more performant. So if you've never heard of it, GSAP is used by a ton of companies, and it's basically a full professional animation library that allows us to create really custom animations. And the great thing is it works on just about anything that JavaScript can touch in the DOM. So in the last section, you saw that I have my little app, but those dice and what's happening is those, the dice rolls and triggers are actually being handled by GSAP itself. Now, this is powerful not just because it can do the animation for us with these 3D objects, but that same pattern that we're using to figure out how we want to spin all of the dice, what we want to happen, we can use that same mental model and framework to directly tween properties on our dice, but we can also use that on SVGs with the same mental model, with images, or with other 3D items inside of the WebGL canvas. So, what happens when we want to make things more complex? Yeah, we can go ahead and roll the dice, but I don't know if you can see a little bit. There is a little confetti animation that happens. The thing with confetti is you throw it up and it comes down, but you never really know exactly where it's going to land. So how do we create something that feels whimsical and doesn't just feel controlled or like very standard? The way that I'm doing this is actually by using a random number generator to generate a random amount of boxes, and then I am directly tweening the properties for rotating, for scale, and for how they dissolve once they come down. Now, this is what helps it feel like an actual pop of confetti in your face, and not like you just have random boxes that are floating from somewhere up and down. This GSAP specifically is what allows us to have dozens of these individual properties, because it would be very tricky to do this manually, even with regular CSS if we wanted to, and it allows us to do it in a performant way. So GSAP recently released their React package, which also gives us access to the use GSAP hook, which makes this a lot more performant. You can think when you have a lot of 3D elements on a page, especially when you're tweening, making changes to how they look and how they feel. This basically gives us an elegant setup and an elegant teardown as well. This is actually what allows good applications to become great animation, or great applications. Not GSAP itself, but that thought in detail about what it's going to look and feel like. Does anybody remember doing those BuzzFeed quizzes to figure out like which Golden Girl you are, or like what, what programming language is like your personality? I used to do those all the time, and you know BuzzFeed quizzes are static. You just fill out the form, you figure out which one it is, and it's nice. Now, what if I told you this is the same experience, but it doesn't look or feel like it? What's actually happening here is this is a very simple, at the heart, a travel quiz to just help you figure out what kind of traveler you are. But you can see that there's a lot of changes in the way that it feels. The items that you're selecting are postcards. How they move and how they fluidly rotate around the page makes you feel like you're looking through pages like you're going somewhere. Those are the little touches that make your website feel like a place and not just a page. And it also goes into the websites that you might see more so every day with these simple gestures of how things fluidly load on the page. It's not very big or grandiose, but it makes you feel like comfortable, like you're there. These are what help our web pages start to feel alive and start to help us make those static pages more so breathing experiences. So we've seen about how our app looks and how it feels and responds to touch, but there is another very powerful subconscious layer that can help guide our users' actual emotions, and that's sound. So I'm going to play a video, and I want you to just think about how it makes you feel. How did it make you feel? Nothing, right? Not really much of anything. Now, I hope the sound will play, but we're going to watch the same video again, and I want you to see how it makes you feel this time. Oh, I'm not hearing anything. Hold on. Let me just put the mic on the thingy-wingy. No? Wait. Don't do that. Okay. Okay, we'll have to pretend because knowing me, I will run out of time. But what actually happened was there's some very suspenseful A24 style music that makes you feel like you might be murdered as soon as you walk into that house. So, is anybody like really afraid of horror? I am. I'm very scared. Okay, so I saved some people today. You're welcome. So, I was going to say, I know what you're probably thinking, but there was no change because there was no music. We used our imagination. But when we think about sound, you might be saying, unsolicited audio on the web, not a good thing. We're no longer in the MySpace days. We are not playing music as soon as somebody hits your page. And you're right, for the most part. But when we think about generative audio, that actually has a very big potential to change how users feel when they come to our sites. Now, generative audio is not a fixed MP3 track. It is actually music that can change depending on a user's state or things that are going on around your application. So this basically means every single time you come to the app, you might have a different soundscape depending on those different factors. Now, for JavaScript and for React developers, Tone.js is one of those items that allows us to create very dynamic music. Now, I do have a demo here for sound. We're put the thinking caps back on. So basically what I did is this app has two different modes, as you can see. One of them is more like a dungeon, kind of dark, kind of gritty, and this one is more like a light, maybe fairy theme. So what I did actually is I wanted these two themes to be very distinct. I wanted the mystical, sort of like dark dungeony part to be like dark NES, I don't know, something game like that. But then when you're in the fairy mode, I wanted it to feel like, whimsical, Zelda, like that's fun. So basically what I did is I was able to create an audio store, and I used that with tools that we're already familiar with in React, like a use ref and use state to keep track of what was going on and keep it stable. And then basically I used random numbers and a random pentatonic scale. It's a minor scale for the sort of like dungeony theme and a major scale for the fairy theme. And I just wanted to randomly generate tracks or notes for all of those individual pieces. So you get something that's like a little bit darker for the dungeon theme and a little bit brighter. But the fun part is it's a loop that consistently is generating, and we don't know what's going to be generated. So you don't really have to get, you don't have to feel like your users are going to be like, oh my gosh, I'm listening to this again and again and again, because it's all random. They don't know what they're going to hear, and you don't either. So if we take this one step further, in thinking about what we can actually do with generative music in the real world, we can think about it to create deeper focus for our users. We can create the sort of score for our applications to also build stronger emotional connections, and we can also use it to make our digital worlds feel more alive when used properly. So we have explored sight, sound, and touch so far. And how am I doing on time? I be yapping, so I'm gonna go ahead and trail the rest of the way through. But what happens when we want to smell things? Now, we do not have smell-o-vision on our computers just yet, so you might be saying, yeah, how are we going to use the sense of smell? You have to go with me here. It's a little bit abstract. Does anybody enjoy wine? A little bit? Okay, in winemaking, there is a concept of terroir. Terroir is the concept that your wine tastes of the places that it's been. So that's going to be the soil, how it was fermented, like where it stayed for a while. And I have coined this digital terroir for sites. Now, this is basically going to be the authentic feel that you are curating for your sites. It's going to be how it feels from the process that you and your team or yourself, all of those parts from the design, from the development, you're putting all of those pieces of your brand or your personality into your sites, and that's what's going to create your digital terroir. So this is what I mean. With a single click, we are transported from a dark mystical dungeon to a light enchanted filled grove. Now these two experiences, while they are fictional, you can sense the atmospheric shift here. Now, doing this smoothly is hard. A lot of times when we change state, it's a very jarring going from one place to another. However, we have a very powerful API called the View Transitions API. And that's what makes it a lot easier to get that nice fade versus an abrupt transition from one place to another. Now, basically what happens, my app is built with just foundational CSS, Tailwind, nothing too complex. So when I want to start a transition, all I have to do is wrap those actions inside of a single line, which is going to be document.startViewTransition, and that takes care of a lot of it for me. So once I want that transition to actually start, a snapshot is going to be created with a static image. It's going to run that callback, and then it is going to create an after image. And then what happens is there is a shadow DOM created to sort of layer those and create that nice, smooth, fading effect for me so we don't jar consumers going from one place to another. Now, this is great by doing it this way, but it also gives us a lot more granular control with two new pseudo elements, view transition old and new, and we can have a lot more granular control about how we do slides or fades or cinematic transitions. So this basically allows us to choreograph the entire atmospheric shift. Oh, my bad, I missed the last two bullet points. Anyway, does anybody love Notion, use Notion all the time? Notion has a very, very strong customer base, and that is not by accident. They have created their own digital terroir that is noticeable from miles away. But it's not just how it looks. It's that people love to physically be in Notion. People love to take their notes in Notion. They love to live there. And by creating that digital terroir themselves, they've created a base for themselves that don't just like their product. They want to be there and will fight to be there. And in a competitive market, that is what keeps people inside of your product. That's your competitive edge. So the last one, taste, this is the one that's going to be our final sense. There is also no taste functionality on our computers just yet. You taste it, it doesn't taste too good. I don't recommend it. But our desire to create and craft those digital spaces is how it started. But today, our taste, you can think about it as you have good taste. You have good taste in fashion. You have good taste. We have good taste as developers in development. And I think a lot of us take pride in that. So what happens when we want to have good taste in development and make sure that our users feel the same way? It all comes to bringing those other senses together and being the conductor of the symphony of those different items. Now, they all may respond to environmental factors a little bit differently, but if everything's reacting on its own, it's going to be chaos. So we have to have that good taste and sort of curate how those things are happening. A simple way that I did that with this is a state management library called Zustard. It's very lightweight, but it is the brain of our application to make sure that when something is changed within an audio component, or maybe when I am changing the theme, that all of the other components react accordingly without having to do a bunch of prop drilling one way or back up to the other. This is basically what allows the sound to ripple through, or maybe for us to hear that change and swap in music, or the view transitions API to happen naturally so we're not jarring people from one place to another. That is our good taste as developers. So why would we ever want to go through all of the trouble of trying to figure out how we could use all of these senses as a developer? When we think about it, the sight of having a 3D product viewer is going to help a purchaser have trust in us and confidence. That touch sensation that we have is going to build the habit of repetition and build trust. The sound is going to build a familiar habit. The smell or the digital terroir and the atmosphere is what's going to build emotional connection and want people to stay in your apps where they are. And then also allowing for taste and customization and for us to be, to do our thing as developers, that's what's really going to build loyalty. So we go from just building disposable apps, and I know we see it every day now with AI just generating all kinds of apps. But using our senses is how we can actually go from, okay, we have an app, to now we have an experience that people will want to come back for years. So this talk was not just about 5 really cool libraries that I think we all should use from time to time. It was more so about a shift in how we think about all of these senses individually and how they can really work together. So at its core, people, us, we are not just purely logical beings, and I think we know that a lot of times, but maybe that gets lost when we think about our apps. We are emotional and sensory beings that crave connection and crave clarity. And when we use those senses, we create applications that give people a sense of belonging. So the web is only becoming more immersive, and I know a lot of us are thinking, AI is here, how do we continue to be good web developers? This is one of those ways. AI can't do this for us. AI can scaffold things for us, but those senses of how it feels about people, about connection, we have entire control over that. So next time you are doing a PR review or you're adding a component or it's a feature, library, I want you to ask yourself not just what should this do, but also ask yourself how does it feel? Take a couple seconds to see, is there something that I can do to make it more user-friendly? Is there something I can do to add an extra response to let people know I hear them, I see them? Use it not as yourself, but as somebody who's never seen this before. And if you start there, then you will be well on your way to creating truly memorable experiences that resonate. Thank you. Thank you.
Chilling. I got food today, that's all that matters.
Huh?
I got food today, so I'm good.
There you go. Yeah, that helps.
That helps a lot. Yeah, that's fine. Where's our next speaker? Jeremy Miller? Jeremy Miller, hello? Is there Jeremy Miller in the house? Is here?
Well, I just thought about hopefully it's smoother this time.
Oh, there he is. Found him.
Yeah, I kind of half stepped in. I copy what Aaron said. Thank you. Anything Aaron says, I say.
Hey, y'all. So right off the bat, this is a little bit miscategorized. The tooling I'm going to show is all .NET based, but we will be talking about some generic concepts. So anybody from the Node.js world here? Okay. So I'm going to talk about a tool called Martin. That's an event sourcing tool, mostly something called Wolverine. In your Node.js world, there is a tool called Emmet, E-M-M-E-T, if you're familiar with it. That is actually by somebody that used to be a core team member for Martin. So check them out as well. All right, tiny bit about me. I'm super caffeinated right now, and I gave a 10-minute version of this talk in the next room last time. So this is about my company, JasperFX Software. It is named after my tiny little hometown in Missouri. That's the sign on the railroad. That is most of the town right there. I'm also the technical leader of the Critter Stack tools. That's going to be the background of what we're doing. .NET tooling. Martin is a Postgres-based event store and also a document database. Who cares? And then Wolverine, that we're going to talk about mostly. It's an application framework, messaging framework, and also an alternative HTTP endpoint model. The reason why it's relevant here, because I really wanted to talk about it, and it's very well suited for this vertical slice architecture approach. All right, so for Generation X folks in the building, that's Conan. And there's a part of the famous part of the movie when Arnold Schwarzenegger could barely speak English when they ask him, you know, Conan, what is best in life? And it's pretty crude. You know, the last 10 years, I've been doing a lot of project rescue work somehow, being called in after the fact, being brought into a lot of well-meaning, clean, onion architecture approaches. Has anybody ever seen a system built on the iDesign architecture style? Oh, y'all are lucky. If you think your clean and onion architecture experiences are bad, you got to see iDesign. The most important thing, what makes a code base, a bigger code base, acceptable to work with, is how easy you can reason about it. And what I mean is, can you understand the system inputs, what kind of changes to the system state get made? Can you, if you have to make new features for a new customer, can you understand easily what the consequences are for making a change up here all the way down there? If you find it hard to follow the code and understand how is it changing the database, you're going to have some trouble. We also need to be able to adapt iteratively as much as possible, and for that you want low code friction. You want as low code ceremony as possible so that it's cheap to just go cut you another web page, go cut you another message endpoint, go cut you something else. If you are tempted, if there is some realistic temptation to just load up more code in existing code, that's when a system is going to get very unmaintainable. And I'm going to say the single most important thing you can ever do, no matter what the technology is, no matter what the system is, it's you need to have effective test automation coverage. If you pick the wrong architecture style, but you have good test coverage, you can reverse that. You can get it fixed. You got a way to change it. This is the single best thing you can ever have. Come on back. All right, this stuff goes wrong. I have another talk similar where, you know, why do enterprise systems go wrong? And I use a slide from The Usual Suspects. Clean architecture, onion architecture, prescriptive architectures, where you get a lot of indirection, a lot of layering, a lot of abstractions, where you have to bounce around the code a lot. Clean architecture, great in theory, in practice, because somebody's going to yell at me that they're doing great with clean architecture. In practice, what can happen is people will build out one project, one horizontal layer with every single bit of data access for the entire project. More layers, more layers. What happens is, if you want to start upgrading technologies, you can't, because you might have to upgrade every single feature in the entire application. Where if you're more vertically aligned, more vertically organized, maybe you could do it bit by bit. The reality is, you want to upgrade some bit of technology, and it means touching every use case in the entire system, you'll never get to do it. Business will never let you do it. Vertical slice architecture is kind of a response to this. All it really means is we're going to try to organize based on functionality instead of technical stereotypes. Story I told in the other room, when I was a very young guy, I got bumped up to the central architect team in a Fortune 100 company in Austin. You guys obviously know who that is. And we decided to go for a heavy CMMI model, heavy waterfall model in the early 2000s. I sat by all the architects on floor number 1, and they were all like COBOL guys. I couldn't even speak to them. The people I actually collaborated with all the time, the developers and testers on the projects I was on, they were like 2 floors up and 100, 200 yards away. And this is before we had IM tools. So I know that sounds horrifying, but it was really hard because the people I really needed to talk to understand the project were way over there. If you were the project manager, you would have had to walk about a half mile to talk to everybody on the team, right? That's kind of silly, but that's my analogy for these clean and onion architectures. So vertical slice, our idea here is we're going to organize our code based on more on use case, more on business capabilities. We're going to put code that is closely related together. I kind of fall into, those are martins, by the way. Kind of look like weasels, pretty cute. Tend to follow CQRS for any kind of real application with any kind of workflow. I won't say that you have to use CQRS for vertical slice, but kind of like peas and carrots, it's going to go together really well. So a slice probably in my mind, refers to a command handler and everything it takes to handle that command, which could be an HTTP endpoint or a message handler most of the time. And then obviously it could be, there's other entry points, which I can't think of at the moment. For .NET folks, almost every example of vertical slice architecture you're going to see is using a tool called Mediator. You can refer to those. Kind of high ceremony. We're going to try to do it a little bit simpler. But moving from a mostly layered perspective to more of a vertical slice, a couple things to think about. Where before you were putting all the controllers together, all the entities together, all the data access pieces together. Instead, let's try to organize around business capabilities. I'm going to show an incident tracking system in a minute. So taking it as an example, instead of having incident controller, an incident service, an incident repository, and separate projects, and everything to do with an incident has to go through those 3 things, right? And they become hugely bloated, because that's how it works. Instead, we might have a log incident file that has the log incident message command. We'll put the message handler right then and there. We might put the data access there. We might put the validation logic. If it's simple enough to be in one file, we're going to put it right there together, right? So that you can more easily reason about what is happening along the way. Something I like other people when they've described this move, they talk about organizing code base on verbs instead of nouns. So instead of being so consumed by what are the things in my system and organizing everything around these giant thing controllers, think about the transactions within the system, the actions within the system. And this again fits really well with the CQRS model, where you are thinking more about business commands or events. Going into our first example, another thing, instead of having a prescription of every bit of your code will follow this exact structure and approach, we're going to allow things to vary a little bit between slices and features. Some features are very simple, so we can kind of cheat and do something really simple. Some things are way too big for these prescriptive approaches, and you got to do something different anyway. My experience with these clean onion architecture code bases, it's the business transactions that are way too big for the prescriptive approach is where you really blow up, because people will stop thinking for themselves. They'll stop pulling extra classes out or even just helper methods. And on that, let's go to a simple, very simple slice. Item service, because I'm super original when I make sample code. If we want to create an item in a message handler, this is a valid Wolverine message handler. It's just a method. There's a lot of naming conventions for how Wolverine finds it. This is a transaction script style that is a very fancy Martin Fowler way of saying just a little bit of procedural code. Taking in a command, I am taking in this items DB context. See, it's Entity Framework Core. It's for Java folks. I'm pulling in Hibernate directly. I'm working with it directly. The only thing is that there is a little bit of Wolverine transactional middleware wrapping around this. It's handling transactions for me. So I don't have to worry about asynchronous code here. That's kind of a nice thing. Do y'all still use synchronous like save methods with Hibernate, or have you don't have any equivalent of async await, do you? How crude.
We don't need it because we have virtual threads.
Oh, okay. You got it a little bit better then. Flipping over, and I'm going to use a little bit more Wolverine magic here. This is the same functionality, but this time I'm putting it into a little HT endpoint, that's goes to a post. Now, a little bit of Wolverine stuff. Now, there's no database stuff going on here at all. We've kind of gone down a functional programming adjacent, functional programming curious type approach. We get to a world where we have pure functions. I push in a command and all the information you might need, and you return some information that tells me what to do next. In this case, we're gonna send an item created message. I don't know, maybe some other bounded context in the system wants to react on it. Maybe this goes to a local queue, maybe it goes to RabbitMQ. We don't really care. We're just deciding we want to raise this kind of event message to let somebody else respond to it. This is a little bit of a Wolverine helper, something we call cascading messages. But the point is, this allows you to kind of create a pretty traceable signature of input to outputs. Insert of item, some people won't like this. It's kind of like a side effect. It's just saying, hey, I want you to go call the ORM, and I want you to insert this new item with all this information. Just do it for me. And this will handle the transaction stuff for you, the async call. We have to do more bookkeeping on async. So that's all that is. All right. Vertical slice architecture, the Wolverine way, the way that we're trying to be successful, we're trying to crush down as much code ceremony as possible. We're trying to remove marker interfaces, attributes as much as possible. We are relying on a little bit of old Ruby on Rails style conventions. Some of the naming conventions matter, but that helps us keep shrinking down the code. Pure functions wherever possible for anything that's business logic related or workflow logic. Anything that's deciding what to do next. Pure function, coming from our FP friends, it's a function that will always respond the exact same way to its inputs. Usually means you have inputs and you have outputs. There are no side effects. It's not writing to a database. It's not writing to a file system. It is always going to behave the exact same way no matter what. From a testability perspective for unit testing, it's perfect because we can just walk right up to this method and say, well, hey, if you have an aggregate like this in this state, and I give you this command, this is what you should decide to do next. A-frame architecture. Let's just get in and look at another example and talk about this a little bit. So now, we are to an incident tracking system. At some point, you may have a command that is categorize incident. Has anybody here used event sourcing? A little bit. So the idea with event sourcing for our persistence, instead of having an incident, we are tracking the changes in state. So almost inevitably, there's little blobs of JSON in the database somewhere. where we're modeling the changes in the system. In this case, the incident was categorized. Now, at some point, the system is going to take all those incident created, incident prioritized, incident categorized, person assigned. It's going to roll those up into a read-only view of what the incident actually is at this current time. What you're seeing right here, this is an example of the decider pattern from event sourcing. If you ever even think about using event sourcing on any platform, I highly recommend looking at this pattern as opposed to an aggregate root. But the goal here is a little bit of help, a little Wolverine magic. We got a little pure function. If I get a categorized incident command, Wolverine is going to go and find the incident for us. It's going to look up in the event store. It's either going to find a snapshot, or depending on how it's configured, or it's going to spit it up on the fly. Doesn't matter. Wolverine kind of on top is going to go get all the information we need. It's going to push it into this pure function. This pure function is going to decide, should I append a new event or not? Simple logic is, if the incident category, if it's already this category, don't do anything. You didn't change. Return nothing. Return a null. But if it did change, I'm going to return a single event incident categorized. On the other end of this, on the back end of this, if there is a response, Wolverine is going to reach into that. It's going to take that. It's going to put that back in the event store. It's going to commit the whole transaction, and off you go. So A-frame. Go get the things that your business logic or workflow logic needs, push it in. When the workflow logic decides what to do next, then carry that out by either changing the database, committing things, whatever it's going to need to be. Talking a little bit about trying to compress the code and keeping everything together. Basic validation. We can also use some middleware that can just validate the command. You have all the expected properties. That's everybody does that now. But let's say you have a little bit more business logic of, should I do this or should I return a different response? Wolverine has a little bit of built-in railway programming as well. That's a kind of a functional programming concept from the F# folks. Think of it as just putting a lot of little guard functions, and again, it's naming convention. But taking this one here, if we are trying to categorize an incident and our incident is already closed, we're rejecting this. We're out of here. It's already done. You're not messing with this anymore, or that's our requirements. So we're going to use the problem details specification, just a convenient way to send some information back to the caller of, hey, nope, this is a bad request. Status code 400, here's the problem with it. Reject it. Wolverine's going to use this little bit of logic. If problem details, the special one, this Wolverine, no problems, keep on going. But if there's something else, it's going to stop the HTTP request. It's not even going to call into this stuff. Hey, 400, I'm going to write out problem details. Again, to this idea of lower ceremony, we're potentially sticking data access, validation logic, real business logic, all directly in the HTTP handler themselves. We didn't delegate from HTTP controller to something else. We're just letting this go because we think we can do this while still allowing for the actual business logic to be isolated from infrastructure. So it's that whole theme of trying to crush things down. Kind of in a world now where everybody expects there to be perfect open API metadata for their HTTP posts. We're also able to look at the type signatures. Wolverine can use that to know the open API metadata will say, hey, I also potentially return a 400 with problem details content type. That's nice. What I understand is the Java guys might have it a little bit better. The .NET world, there can be a little bit of mystery meat in our web controller stuff or minimal API where you have to do a lot of explicit junk code to get really good open API. So we're trying to sidestep that by being able to derive much more of it from your code. Again, to just the theme, every possible thing you can do to shrink your code down so it's easier to read, And it's also easier for you to just pop out and create a new message handler or HTTP endpoint later. All right. So code organization, some people really get obsessed with this. You know, what should my folder structure look like? What should everything be named? I don't have a lot of strong opinions other than to say code that is closely related is code that you have to read all together to truly understand. Put it closer together in your file system, even if that's not in the same file, same namespace, same folder. Code that's not related can be separated. I actually like to have data access code, especially if it's data access code that is specific for a single command handler endpoint. I want that as close as possible to that endpoint. Rather than having like a separate incident repository with every possible query you're going to do waste somewhere else, I want to be able to see as closely as possible, even in the same file, what did I do? What data access calls, what database calls did I do? This kind of means I usually push clients to don't put any kind of abstraction wrapper around your data access tooling. We're going to rely much heavier on this A-frame way of separating your data access from your business logic without needing a lot of abstractions, and definitely not set yourself up for mock object hell. Let me look at another, I want to show another example, slightly more complicated data access. So, you know, during COVID, if you had kids or really yourself, you did a lot more telehealth sessions than you'd ever done in your life. So one of the things I got to do, really fun project on Node.js, actually. Got to help a startup build a new telehealth system. I have no idea if it ever went into production, but it was a fun project. So just the way we had it modeled, I want you to look at this method right here. So some of the things you need to know is there might be a board. And what this really means is maybe it's like pediatrician appointments in Central Texas on this day. You know, just a board of who are the waiting appointments, who are the providers. We're going to mix and match, get you an appointment, get you in, and they're going to tell you to go, you know, go get tested for COVID, right? And then we also need to know a little bit of information about a provider. What kind of licenses do you have? And sorry, provider, physician assistant, maybe a nurse, maybe the actual doctor. But you need to know things like, are you actually licensed to do pediatrics in Texas or Louisiana or wherever it's going to be? So this little bit of method here, this little slice that is, starting a provider shift. And one of the things we need to do is just validate, hey, you know, are you allowed to be in this room with this logical group of appointments? So I need to know two things. Tried to make the point that chattiness to a database is one of the leading killers of performance in enterprise systems across the board. I think it's the single biggest cause of performance problems, partially because you can't even see how many data access calls you're doing. One of the things I do not personally like about abstracting away the database, really your persistence, it takes away all the advanced tech that you have at your disposal, whatever your tooling is. So what I'm showing right here, this is using Martin for persistence. It's like DynamoDB, I guess, Cosmos DB. It's a document database. One of the things it can do is it can batch up queries for you. It's a little more code. It's not going to fit well behind an abstraction that you could then flip in for something else. But in this isolated method, we're going to go look up the board and provider referred to by the command all at once. We're going to make one round trip, get all the information we need. That's performance gain. And again, we're still doing some A-frame stuff. This specific bit of querying, it's right here. I'll just scroll down a little bit more in our slice. You know, there's some extra validation. We're going to do a little bit of validation of can the provider actually join this board? And if not, we're going to return a problem details 400. Nope, no good. And here's why. And then finally, our happy path down at the bottom This is the little bit of decider pattern of what to do next. In this case, we're going to start an all-new event stream for the provider shift. The provider coming on for this day on this board, what that means. We're going to return some kind of side effect kind of things of just telling Wolverine, hey, this is what I want to do. I'm going to decide to do this. I can write a unit test directly against this, and I can test that I got exactly the event and the new event I wanted. You can test all the left-hand, right-hand mapping that might be there. The shift starting response, this will go into the HTTP response. It's going to do a 202 response status code, and it's going to have a URL directly to where the new provider shift is. But these things end up being relatively testable. And I think on that one, definitely avoid deep call stacks. There's a lot of other stuff you can ask me about after this. And then, thank y'all. This is a super heavily caffeinated. This is supposed to be like an hour and 15-minute talk. Thank y'all. I am out of time.